Consider the moment when millions of people across the world simultaneously recall something that never actually happened, a collective memory so vivid and detailed that it persists even after being confronted with evidence to the contrary. And this phenomenon takes its name from the widespread false recollection that Nelson Mandela died in prison during the 1980s, when in fact he was released, became president of South Africa, and lived until 2013. Yet thousands of individuals claim with absolute certainty that they remember hearing about his death in captivity, watching funeral broadcasts, and discussing the tragedy with friends and family, creating a shared false history that binds people together across continents and cultures. The mechanism behind this curious mental phenomenon operates through several interconnected psychological processes that shape how our brains encode, store, and retrieve information. Beginning with the simple fact that human memory is fundamentally reconstructive rather than reproductive, meaning that each time we recall something, we are not simply retrieving a stored file, but rather rebuilding the memory from fragments and associations. And this reconstruction process is highly susceptible to influence from our expectations, beliefs, and the information we encounter after the original event. When large groups of people share similar cognitive biases, similar patterns of attention, and similar cultural references, these individual memory reconstruction processes can converge toward the same false conclusion, creating what researchers call false consensus, where the simple existence of other people confidently affirming the false memory reinforces the neural pathways associated with that false version, making it feel increasingly real and authentic to the individual, even as objective evidence contradicts it entirely. Consider the moment when you walk into a room you have never entered before, yet every detail feels impossibly familiar, as though you have lived this exact instant countless times already. The arrangement of furniture, the quality of light filtering through the windows, the exact cadence of a conversation happening nearby, the precise smell of the air, all of it resonates with a certainty that defies rational explanation. You pause, caught between the knowledge that this is genuinely new and the overwhelming sensation that it is genuinely ancient. This is déjà vu, from the French phrase meaning already seen, and it represents one of the most prevalent yet thoroughly unexplained experiences in human consciousness. Scientific psychology has offered explanations centered on memory retrieval errors, proposing that the brain occasionally misfires in its filing systems, retrieving a similar memory and presenting it as the present moment, or suggesting that familiar elements within a new situation trigger a false sense of recognition. Neurologists have pointed to temporal lobe anomalies and the complex interplay between the hippocampus and surrounding memory structures, theorizing that the brain somehow processes current sensory information through both the novel and familiar neural pathways simultaneously, creating a cognitive collision that registers as impossible recognition. Yet despite decades of research and computational modeling, the mechanism remains elusive, and the frequency with which people experience déjà vu, studies suggest up to 70% of the population has encountered it, seems disproportionate to our understanding of how memory actually works. What is particularly striking is how we have collectively normalized this glitch, treating it as a minor neurological curiosity rather than questioning why our consciousness would possess such a consistently malfunctioning feature. We speak of it casually, laugh it off at dinner parties, and move forward without considering that in a properly functioning biological system, present moments should never feel like perfect repetitions of moments that never occurred. The experience persists despite being logically impossible, and we have learned to accept it as simply part of being human, never quite reconciling the contradiction between its ubiquity and its fundamental inexplicability. Perhaps the real glitch lies not in the mechanism itself, but in our willingness to accept a phenomenon that should theoretically never happen, suggesting that consciousness harbors mysteries far deeper than any neuroscientific model has yet accounted for. One of the most widely reported and discussed anomalies in collective memory involves the spelling of a beloved children's book series that has existed since 1958, a series that introduced generations of readers to a family of anthropomorphic bears living in a tree house and navigating wholesome adventures in their forest community. The books are spelled Berenstain, with an AI combination near the end, yet countless individuals across multiple generations distinctly remember the spelling as Berenstain, with an EI combination instead, a discrepancy so pervasive that it has become one of the most documented examples of what researchers call the Mandela effect. named after the widespread false memory that Nelson Mandela died in prison during the 1980s when he actually survived to become president of South Africa. The Berenstain Bears phenomenon is particularly striking because it involves not just casual observers, but individuals who grew up reading these books, parents who read them to their children, teachers who used them in classrooms, and people who worked in libraries and bookstores where they encountered these books regularly across decades. The psychological mechanism underlying this phenomenon appears rooted in pattern recognition and linguistic expectation, as the human brain tends to normalize spelling patterns it encounters, and the suffix stein is far more common in English than stain, particularly in proper names, creating a cognitive bias that leads our minds to reconstruct the spelling according to what feels more familiar and linguistically probable. When people encounter the correct spelling of Berenstain, their brains unconsciously correct it to match the more common naming pattern they expect, a process that occurs so seamlessly that the false memory becomes encoded as firmly as genuine memories. And when these individuals later recall the name from memory without visual reference, their brains retrieve this reconstructed version rather than the actual spelling. What makes this anomaly particularly unsettling is that it persists despite ready access to verification, as anyone can check a physical book or search online to confirm the actual spelling. Yet the false memory often remains resilient even after encountering the correct information, suggesting that our confidence in our own memory systems may be fundamentally misplaced, or that certain memories operate according to different rules than we understand. Consider the strange behavior of quantum particles at the smallest scales of reality, where an electron or photon seems to behave differently depending on whether or not someone is watching it, a phenomenon that has perplexed physicists since the early 20th century when quantum mechanics emerged as our best description of subatomic reality. When scientists conduct an experiment without measuring or observing a particle's properties, it behaves as though it exists in multiple states simultaneously, a condition known as superposition, spreading out as a wave of probability across space. However, the moment a detector is placed in the experiment, the moment an observation is made or a measurement is taken, the particle appears to snap into a single definite state, collapsing the wave of possibility into one concrete reality, as though the act of observation itself has fundamentally altered the nature of existence at the quantum level. This phenomenon, known as the quantum observer effect, suggests something deeply unsettling about the relationship between consciousness, measurement, and physical reality, implying that the universe does not exist in a determined state independent of our interaction with it, but rather that observation plays a constitutive role in actualizing reality from a field of pure potential. The mechanism behind this phenomenon rests on a subtle but crucial distinction between the metaphorical language we use and the actual physics involved, though this distinction often becomes blurred in popular culture and casual discussion. What is happening is not that human consciousness or awareness literally collapses quantum wave functions through some mysterious psychic force, but rather that any act of measurement necessarily involves an interaction between the measuring apparatus and the system being measured, and at quantum scales, this interaction is never negligible or ignorable. To measure the position of an electron, for instance, a physicist must shine light upon it, and that light carries energy in discrete packets called photons, and when a photon collides with the electron, it imparts momentum and energy that disturbs the electron's state, fundamentally altering what you were trying to measure in the first place. The mathematical formalism of quantum mechanics describes this situation precisely, showing that the uncertainty principle prevents us from knowing both the position and momentum of a particle with arbitrary precision simultaneously, because any attempt to refine one measurement necessarily obscures the other. Consider the double-slit experiment, one of the most foundational observations in quantum mechanics, where particles of light or matter are fired toward a barrier containing two adjacent openings, and what occurs on the other side defies our everyday intuitions about how the physical world should behave. When no observation takes place, when no measurement apparatus is directed at the slits to determine which path each particle actually takes, the particles behave as waves, passing through both openings simultaneously and creating an interference pattern on a distant screen, a pattern that only emerges when entities exist in a superposition of states, spreading across multiple possibilities at once. However, the moment a detector is placed at either slit to catch the particle and force it to reveal which opening it genuinely passes through, the particles immediately abandon their wave-like behavior and act instead as discrete particles, each choosing one slit or the other, and the resulting pattern on the screen collapses into two distinct bands rather than the intricate interference stripes. This observation introduces a profound logical tension. The act of measurement itself appears to alter reality, as though the universe responds differently depending on whether anyone is paying attention, as though consciousness or observation contains a causal power that collapses quantum possibilities into singular outcomes. The mechanism underlying this persistent puzzle involves our fundamental assumptions about the separation between observer and observed, about whether properties exist independently before measurement or only come into being through the act of measurement itself, about whether reality requires a witness to solidify into definite form. What makes this particularly unsettling is not merely the phenomenon itself, but how thoroughly it has become normalized within our scientific frameworks, how we have constructed elaborate mathematical formalisms to describe and predict it without ever truly resolving the conceptual impossibility it represents, without ever explaining why measurement should possess such power over physical reality. We continue teaching this experiment, continue measuring and predicting its outcomes with remarkable precision, continue building technology upon foundations that rest upon this unresolved tension, all while the fundamental question lingers unanswered in the background, whether the universe requires observation to exist, or whether our observation somehow creates the very reality we believe we are merely discovering. Consider the peculiar phenomenon where observers report moments of visual degradation in their everyday perception, where the continuous flow of sensory information appears to break down into discrete, blocky units, as though the world itself has momentarily reduced its resolution, and what was once smooth and seamless suddenly transforms into something resembling the low-fidelity graphics of early digital systems, with edges becoming jagged and details collapsing into larger, undefined shapes that lack the intricate information we expect from reality. These reports emerge from people across different backgrounds and cultures, describing instances where their vision seems to stutter or pixelate for brief seconds, particularly during moments of extreme stress, sleep deprivation, or the strange liminal spaces between wakefulness and dreaming, when the human mind exists in that vulnerable threshold where consciousness loses its firm grip on the mechanisms of perception. The psychological explanation points toward how attention operates as a selective filter, how our brains construct reality not from complete data, but from samples and predictions, filling in vast portions of our visual field with assumptions based on what we expect to see rather than what we actually process moment to moment. And when this predictive system becomes overwhelmed or destabilized, it occasionally fails to maintain the illusion of continuous, high-resolution reality, leaving gaps where the underlying mechanism becomes briefly visible. The phenomenon also connects to how visual processing actually works at the neurological level, how information is compressed and transmitted through neural pathways, how our eyes make constant micro-movements called saccades to gather data, creating the impression of seamless vision from what is actually a series of sampled glimpses stitched together by our consciousness into a coherent whole. Consider the fundamental architecture of reality itself, particularly the smallest measurable unit of distance that physics permits us to conceive of or observe, a threshold known as the Planck length, approximately 1.6 times 10 to the negative 35 meters, a scale so infinitesimally small that it exists beyond our capacity to probe experimentally with any technology conceivable within the foreseeable future. At this boundary, the very concepts we use to describe space and distance begin to lose their conventional meaning, and yet physicists propose that below this threshold, the familiar geometry of spacetime itself may dissolve into quantum foam or become fundamentally indivisible, unable to be subdivided further. The peculiar anomaly emerges when we contemplate what this limit truly represents within a simulation hypothesis framework. If reality operates as a computational process, then the Planck length could theoretically function as the minimum resolution, the smallest unit of pixelation or discrete information required by whatever system processes and renders our universe, analogous to how digital images cannot display details smaller than their pixel size, no matter how powerful the viewer's perception becomes. What strikes us as philosophically unsettling is that this fundamental limit exists not merely as a measurement we cannot surpass with current instruments, but as an apparent hard boundary built into the mathematical structure of quantum mechanics itself, suggesting the universe actively prevents us from accessing information below this scale through physical law rather than through mere technical limitation. The mechanism underlying our psychological acceptance of this boundary stems from our deep conditioning to trust mathematical formalism and the predictive success of quantum theory, which has proven so devastatingly accurate that we rarely question whether those equations describe fundamental reality or merely describe the limitations of our simulation's rendering engine. We have normalized this peculiar fact by abstracting it into respectability, discussing it in academic journals, and integrating it into our theoretical models as though it represents a natural property of existence rather than potentially representing the resolution limit of our computational substrate. And in doing so, we have transformed what might be evidence of artificial constraint into an accepted principle of physics. Consider the fundamental constant that sits at the heart of modern physics: the speed of light, approximately 300,000 kilometers per second, a boundary that nothing with mass can ever reach or exceed according to Einstein's theory of relativity. This speed limit appears throughout our universe with remarkable consistency, observed in particle accelerators, astronomical measurements, and the behavior of electromagnetic radiation traveling across the vast distances between stars. Yet when we examine the actual evidence for this universal speed cap and contemplate what it truly means, certain peculiarities begin to emerge that warrant deeper consideration. The speed of light was not always treated as an absolute limit. In fact, early theories of gravity proposed instantaneous action at a distance, suggesting that gravitational effects propagated infinitely fast through space. Yet this mechanism was eventually replaced by the relativistic model where nothing can travel faster than light. What remains curious is how consistently this exact speed appears as a barrier in our universe, as though some cosmic programmer had implemented a maximum velocity constraint into the fundamental code of reality itself. Consider that in computer simulations and video games, developers routinely implement speed caps to prevent objects from moving too fast, ensuring stability in the physics engine and preventing calculations from breaking down. The speed of light functions precisely this way in our universe, serving as a computational boundary beyond which certain equations become undefined or produce imaginary numbers. We have normalized this speed limit so thoroughly that questioning it seems almost heretical within scientific circles, yet the mechanism by which this limit enforces itself remains genuinely mysterious. Particles approaching the speed of light experience relativistic effects: time dilation, length contraction, and increasing mass, all of which conspire to make acceleration toward light speed progressively more difficult, as though the universe itself actively resists any attempt to breach this threshold. It is as though the fabric of reality has been engineered with a hard cap, a speed governor built into the laws of physics themselves, preventing any object from ever quite reaching the cosmic speed limit, no matter how much energy is applied. Consider the phenomenon of quantum entanglement, which describes the relationship between two particles that have become correlated in such a way that the quantum state of one particle cannot be described independently of the other, no matter how far apart they are separated in space. When physicists measure a property of one entangled particle and observe it to have a specific value, the corresponding measurement of its partner particle will instantaneously reflect a correlated value, even if that second particle resides on the opposite side of the observable universe. This is not a transmission of information through space in the conventional sense, yet the correlation appears instantaneous, seemingly defying the classical understanding that nothing can travel faster than light. In laboratory settings, researchers have repeatedly demonstrated this phenomenon through experiments involving photons, electrons, and other quantum systems, confirming that these correlations are real and measurable, not merely artifacts of incomplete knowledge or hidden variables that we have yet to discover. The mechanism operates at a level of reality so fundamental that it challenges our intuitive understanding of locality and causality, forcing us to reconsider what we mean by separation and independence in the physical world. The strangeness deepens when we recognize that neither particle has a predetermined state before measurement occurs. Rather, the act of measuring one instantaneously determines what the other will become when measured. This suggests that reality itself may not possess definite properties independent of observation, or that the universe operates according to principles fundamentally different from our everyday experience suggests. What is remarkable is how thoroughly we have normalized this deeply counterintuitive aspect of nature, integrating it into accepted physics without fully resolving the philosophical implications it carries. Scientists continue developing applications based on quantum entanglement without necessarily agreeing on what the phenomenon truly reveals about the nature of reality. Whether it indicates genuine non-locality, suggests the existence of parallel universes, or points towards some deeper framework we have not yet understood. The contradiction persists at the heart of modern physics, unresolved yet operationalized, accepted yet unsettling, suggesting that perhaps the fabric of reality contains layers of interdependence and instantaneous connection that cannot be reconciled with our classical notion of how the universe should function. In quantum mechanics, there exists a phenomenon so peculiar and foundationally troubling that it has resisted complete explanation for over a century, and that phenomenon is what physicists call wave function collapse. According to the mathematical framework of quantum theory, particles exist in a state of superposition, meaning they simultaneously inhabit multiple potential states or locations until the moment they are observed or measured, at which point this superposition mysteriously collapses into a single definite state. This collapse happens instantaneously, with no apparent mechanism or explanation for how observation itself can alter physical reality so dramatically and fundamentally. The measurement problem, as it is formally known, suggests that the act of looking at something changes what it is, which violates every principle of classical physics and common sense reasoning that we have developed through centuries of scientific progress. What makes this phenomenon even more unsettling is that physicists cannot agree on what constitutes an observation, whether consciousness plays a role in collapse, or whether collapse even represents something physically real occurring in nature or merely a mathematical convenience for calculations. The psychological mechanism at work here involves the human tendency to compartmentalize unexplained phenomena into domains where they seem less threatening to our understanding of reality. We have accepted wave function collapse not because we understand it, but because the predictive power of quantum mathematics works so extraordinarily well that we have learned to suspend our demand for intuitive physical explanation. This represents a fundamental shift in how science operates, moving from seeking mechanistic understanding to accepting probabilistic description. Our minds have adapted to this conceptual incoherence by treating the quantum realm as somehow fundamentally different from everyday experience, as though different rules might legitimately apply at different scales, though no one has ever demonstrated why this should be true. What persists most troublingly is that this foundational mystery remains completely unresolved despite tremendous intellectual effort and financial investment. Yet we proceed with quantum technology and quantum computing as though the underlying question has been solved. The normalization of this gap between what we can do and what we can explain suggests a deep comfort with not truly understanding the universe at its most fundamental level, a resignation to living within mathematical abstractions rather than physical reality. Consider the universe as a vast computational system operating on principles remarkably similar to cellular automata, where reality itself might be constructed from discrete units of information governed by simple, deterministic rules that propagate through space and time in synchronized generations. In cellular automata models, each cell exists in one of several possible states, and the state of every cell in the next generation depends entirely on its current state, and the states of its neighboring cells according to a fixed set of rules, creating complex emergent behaviors from these elementary interactions. The striking observation here is how our universe exhibits properties that align uncannily with this theoretical framework. Quantum mechanics shows us that reality operates in discrete packets of energy called quanta rather than smooth continuums. Particles exist in quantized states and transitions between them, and the universe appears fundamentally computational at its deepest level, with information being the primary substance rather than matter and energy. What makes this phenomenon psychologically compelling is that we have independently discovered that the most elegant mathematical descriptions of reality involve discrete systems and algorithmic processes, suggesting that consciousness and mathematics are converging on the same underlying structure. We observe that complex life, whether patterns, galactic formations, and the evolution of species all emerge from remarkably simple rules applied consistently across vast populations and time scales, precisely as cellular automata would predict if we lived within such a system. The mechanism operating here involves our brain's pattern recognition capacity seeking coherence between abstract mathematical models and empirical observation, compelling us to notice how well simple rules generate infinite complexity. Yet what persists despite having no definitive proof is a subtle cultural acceptance that reality might genuinely be computational, that we might be existing within layers of cellular automata stacked upon one another, where what we perceive as continuous spacetime is actually discrete generations of information updating in lockstep. And what we experience as free might be the inevitable result of deterministic rules so complex that they produce apparent randomness and consciousness as emergent properties. In 23, philosopher Nick Bostrom presented what would become one of the most mathematically elegant arguments for simulation theory, a logical framework so tightly constructed that it offers no escape route, only a choice between three equally unsettling conclusions. The trilemma states that at least one of three propositions must be true. Either civilizations almost always go extinct before reaching a technological level capable of running detailed ancestor simulations, or advanced civilizations choose not to run such simulations for reasons we cannot fathom, or we are almost certainly living inside a simulation created by a more advanced civilization. The elegance of this argument lies in its mathematical inevitability rather than empirical evidence, yet it has become the cornerstone of simulation discussions across academia, technology sectors, and popular discourse. When you examine the logical structure, you find yourself unable to dismiss any single premise without accepting something equally profound, which creates a psychological trap where your mind circles endlessly through the possibilities. The mechanism underlying this phenomenon is partly mathematical, since probability distributions across three mutually exclusive outcomes leave no neutral ground, but it is also deeply psychological, as the trilemma exploits our discomfort with accepting premises that challenge our ontological status. We have normalized this argument despite its inherent discomfort by treating it as a sophisticated thought experiment rather than a literal claim about reality, allowing us to engage with its implications academically while maintaining psychological distance from its existential weight. The trilemma persists in cultural consciousness precisely because it cannot be disproven through observation alone, and because each of its three horns points toward mysteries that science has not yet illuminated, making it a permanent fixture in discussions about technological futures and the nature of reality itself. Yet the trilemma's grip on our imagination reveals something perhaps more important than the simulation question itself. Our species has reached a threshold where we must seriously contemplate our own origins, suggesting that the framework matters less for its truth value than for what it signals about our evolving relationship with technology and reality. In recent years, Elon Musk has become one of the most vocal public figures discussing the possibility that our reality might be a simulation, presenting what many regard as a compelling probabilistic argument that has garnered significant attention across mainstream media, academic discussions, and popular culture. His reasoning follows a straightforward logical framework. If civilizations continue to advance technologically over sufficiently long timescales, they would eventually develop the capacity to create increasingly sophisticated simulations of reality, potentially achieving fidelity so perfect that the inhabitants within those simulations would be entirely indistinguishable from base reality, and therefore, if such technological advancement is possible, the odds that we exist in the original base reality rather than in one of potentially billions of simulated realities become statistically infinitesimal, with Musk estimating the probability of us living in base reality at perhaps 1 in billions. What makes this argument particularly fascinating from a simulation anomaly perspective is not whether the argument itself is logically sound, but rather how quickly and thoroughly it penetrated mainstream consciousness despite being neither new nor scientifically testable, and how Musk's particular presentation of this ancient philosophical concept became treated as a novel insight deserving serious consideration by everyone from Silicon Valley entrepreneurs to conventional scientists. The mechanism behind this phenomenon appears rooted in a combination of authority bias, where statements from billionaire technologists carry disproportionate cultural weight, and our collective desire to find rational explanations for the uncanny experiences and inexplicable coincidences that pepper ordinary life. When Musk articulates this argument, he provides a permission structure for people who have long harbored suspicions about reality's fundamental nature, transforming what might be dismissed as conspiratorial thinking into something appearing intellectually rigorous and probabilistically grounded. Consider the profound observation that the universe, in its entirety, appears to operate according to mathematical principles with an almost unsettling precision, as though the fundamental fabric of reality itself is not made of matter or energy, but rather woven from pure mathematics and abstract numerical relationships that seem to exist independent of any physical substrate. The mathematical universe hypothesis proposes that this is not merely a coincidental alignment, but rather the deepest truth of existence itself, suggesting that mathematical structures are not simply useful tools we have invented to describe reality, but that reality literally is mathematics, with all physical phenomena being nothing more than manifestations of mathematical patterns that would exist and behave identically even if no conscious observers were present to perceive them. When we examine the behavior of particles at quantum scales and galaxies at cosmic scales, we find that elegant equations capture their dynamics with remarkable accuracy, from Maxwell's equations describing electromagnetism to Einstein's field equations governing gravity, as though some invisible mathematician has authored the universe according to principles of mathematical beauty and symmetry that human mathematicians, through centuries of discovery, have gradually uncovered and documented. The profound strangeness emerges when we recognize that mathematics itself requires no physical instantiation to exist, yet our universe appears to be fundamentally mathematical in nature, raising the circular question of why mathematical structures should correspond so perfectly to physical reality, or whether perhaps the distinction between abstract and physical is itself an illusion created by our limited perspective. We have normalized this astonishing alignment by gradually accepting that mathematical descriptions are simply how science works, integrating the concept so thoroughly into our worldview that we rarely pause to consider the sheer improbability that billions of years of cosmic evolution should produce a universe whose behavior can be reduced to abstract symbols manipulated according to logical rules. Yet this normalization represents a kind of cognitive acceptance of something that remains fundamentally inexplicable within our conventional understanding of how existence should function. Consider the peculiar phenomenon of how information and experience seem to deteriorate the moment we attempt to retain them, how conversations fragment into scattered recollection, how entire events collapse into a single sensation or emotion rather than a coherent narrative that we can reliably reproduce. We move through conversations with friends and find ourselves unable to recall the specific words exchanged, only the general feeling that something important was discussed, as though the dialogue itself was never truly encoded in the first place. We watch films that captivate us entirely in the moment, yet days later we retain only fragmented imagery, a disconnected sequence of scenes without the emotional throughline that made them coherent during viewing. Books we read with complete absorption leave behind only vague impressions and perhaps a single sentence that lodged itself in our consciousness, while the architecture of ideas, the careful construction of narrative momentum, dissolves almost immediately into abstraction. We experience what feels like complete understanding during a lecture or presentation, only to discover hours later that we cannot articulate what was explained or reconstruct the logical sequence that seemed so clear moments before. This degradation of information occurs not because our memory is simply weak, but because it appears that the experience itself, once it passes the threshold of the present moment, becomes systematically simplified, reduced to its essence, stripped of the granular detail that would make it reproducible. The mechanism behind this appears to be related to the way consciousness processes information in real time versus how it stores that information for later retrieval. In the moment, we engage with full sensory input, emotional response, and immediate context, creating an illusion of complete comprehension and retention. Yet the actual encoding process seems to extract only certain fragments, certain emotional markers, certain key details, while allowing the majority of what occurred to simply vanish into inaccessibility. We have normalized this as merely how human memory works, attributing it to capacity limitations or the inevitable decay of neural patterns. Yet this explanation feels insufficient when we consider how we can remember with extraordinary detail certain trivial moments from childhood, while simultaneously losing track of events from yesterday with relative ease. Consider the peculiar observation that emerges when physicists examine the fundamental nature of reality at its smallest scales, a principle suggesting that all the information contained within a three-dimensional volume of space can be entirely encoded on its two-dimensional boundary surface, much as a hologram contains a three-dimensional image compressed onto a flat photographic plate, and how this theoretical framework, while remaining deeply speculative and unproven, has nevertheless become woven into mainstream theoretical physics discourse in ways that defy our intuitive understanding of dimensional space and information storage. The holographic principle originated from black hole thermodynamics research, where scientists discovered that the maximum entropy of a black hole, the measure of information it could contain, scales with its surface area rather than its volume, a mathematical relationship that seemed to suggest that a three-dimensional object's complete description might require only two-dimensional information. Yet when we examine the broader implications of this principle, we find ourselves contemplating a reality fundamentally different from our perceived experience, one where depth and dimensionality, as we understand them, may be illusory projections from lower-dimensional data sources. The psychological mechanism sustaining belief in this principle, despite its abstract and untestable nature, rests upon mathematical elegance and the historical precedent of counterintuitive physics proving correct, where previous generations dismissed non-Euclidean geometry and quantum superposition until experiments validated them, creating a cultural momentum within the physics community that treats the holographic principle as potentially revelatory rather than speculative. A framework that offers profound answers to fundamental questions about consciousness, information, and the structure of existence itself. Yet what remains striking is how thoroughly this principle, which contradicts everyday spatial experience and remains unobservable through current technological means, has infiltrated educational curricula, popular science narratives, and even philosophical discussions about the nature of reality, becoming accepted not through direct evidence but through mathematical consistency and the authority of prestigious institutions. All while we continue navigating a world that appears unambiguously three-dimensional, never directly experiencing any evidence of our own existence being projected from a lower-dimensional surface, a disconnect that persists without resolution or acknowledgement. Consider the phenomenon of how the night sky appears to our perception as a vast dome or ceiling stretching infinitely above us, a cathedral of stars that seems to curve gently around our position as if we occupy the center of all creation. This perceptual experience has persisted for millennia, and remarkably, it continues to influence how we unconsciously visualize and conceptualize the cosmos, even after centuries of scientific advancement that has thoroughly proven the three-dimensional nature of space and our insignificant peripheral position within it. The analogy is peculiar but worth examining. Our subjective experience of the heavens resembles the projection surface of an old cathode ray tube monitor, where the curvature of the screen creates a bounded visual field that appears complete and whole despite being fundamentally a flat representation of depth. Our brains process the night sky through this innate cognitive framework, receiving flat visual information across our retinas and constructing a sense of an enclosed space above, much as a CRT screen receives electron beams and transforms them into the illusion of three-dimensional imagery through careful manipulation of perception and timing. The stars appear equidistant from us, arranged on the inner surface of this imagined sphere, when in reality they exist at vastly different distances, some light years apart, their true spatial relationships invisible to our direct perception. We have intellectually accepted heliocentrism and understood the expanding universe, yet the primordial perception persists unchanged in our direct experience, our consciousness still rendering the cosmos as a contained system with ourselves at the origin point looking outward at a ceiling of light. This disconnect between our intellectual knowledge and our experiential reality remains largely unexamined, a fundamental glitch in the interface between what we know and what we perceive, suggesting that our consciousness operates through a rendering system as limited and bounded as any technological display, processing infinite information into a finite, manageable viewscreen of experience that we mistake for complete reality. Perhaps this is why we find it so difficult to truly internalize the scale of the universe, or to viscerally understand our own cosmic insignificance. Not because the information is unavailable, but because our perceptual apparatus remains locked in a rendering mode designed for a hunter on a savanna, forever refreshing a skyward display that prioritizes what is visible and immediate over what is mathematically true. Consider the fundamental fabric of reality as physicists understand it through the lens of quantum mechanics and general relativity, where the smallest possible unit of space itself is theorized to be the Planck length, approximately 1.6 times 10 to the negative 35 meters, a scale so incomprehensibly minute that it sits at the absolute boundary where our current laws of physics cease to function meaningfully. This Planck scale represents a kind of cosmic granularity, a theoretical pixel size for the universe itself, suggesting that space and time might not be infinitely divisible, but rather composed of discrete, quantized packets of existence, much like how a digital screen composed of individual pixels creates the illusion of continuous smooth imagery when viewed from a distance. Now here exists a peculiar cognitive resonance in how modern physics has arrived at this conclusion through purely mathematical and experimental reasoning. Yet the metaphor of pixels, of digital information units, emerges so naturally and repeatedly in our descriptions of this phenomenon that it becomes difficult to separate the genuine physics from the human tendency to filter the universe through the technological frameworks we have created in our current era. The mechanism underlying this convergence likely stems from our evolved pattern recognition systems combined with our deeply technological context, wherein we unconsciously map unfamiliar scales and concepts onto familiar digital structures that have become central to our contemporary experience, making the pixelated universe not merely a helpful analogy, but somehow a framework through which we genuinely attempt to comprehend reality itself. What persists despite the arbitrary nature of this comparison is the subtle entrenchment of digital metaphors into our fundamental understanding of physics, to the point where academic papers, popular science discussions, and educational materials routinely employ pixel and grid analogies when discussing quantum foam and spacetime granularity, essentially normalizing a technological interpretation of nature that may say more about our present moment than about the actual structure of existence. The simulation hypothesis naturally feeds upon this conceptual overlap, proposing that if the universe operates on discrete units like a pixel, then perhaps these pixels represent computational units rather than mere mathematical abstractions. A seductive logical leap that our minds make almost automatically when confronted with the pixel metaphor presented as serious physics. Consider the peculiar nature of human perception and how we experience the flow of time itself, a phenomenon that bears an uncanny resemblance to the concept of frame rate in digital systems. When you observe the world around you, your consciousness receives information through your sensory organs at a specific rate, a biological sampling frequency that defines the resolution at which you perceive reality. Your eyes, for instance, process visual information through a series of snapshots rather than in one continuous stream, with research suggesting that your visual perception updates approximately 13 to 20 times per second under normal circumstances, though this varies depending on attention and stimulus complexity. Between these individual frames of perception, there are gaps, microseconds and milliseconds where your consciousness is not actively processing new information, yet you experience no discontinuity, no flickering, no awareness of these missing moments at all. Your brain fills in these gaps seamlessly through a process called temporal interpolation, constructing a sense of smooth, continuous reality even though what you are actually experiencing is fundamentally fragmented and discontinuous. Similarly, when you observe moving objects or rotating phenomena, there exists a threshold beyond which your eyes can no longer resolve the individual components of motion, and instead perceive what appears to be smooth transitions between positions, yet this smoothness is an illusion generated by the limitations of your perceptual frame rate. This same principle manifests in human experience through instances where events seem to slow down during moments of extreme stress or danger, suggesting that your conscious sampling rate can actually fluctuate based on mental state and attention levels. What is remarkable is that we have built our entire understanding of reality on the assumption of continuous time and perpetual observation, yet the evidence of perception itself suggests something far more discrete and segmented. We navigate the world based on the belief that we are experiencing all of time as it passes, when in actuality we are receiving a limited sampling of reality and our minds are working diligently to convince us that we are witnessing something unbroken and whole. Throughout daily life, most people encounter individuals who seem to operate according to rigid, predetermined patterns of behavior, repeating the same phrases, reactions, and routines without apparent deviation or genuine engagement with their surroundings, moving through their environments with mechanical predictability, as though following an invisible script that guides every interaction and response they make. These observations range from the casual acquaintance who always tells the same jokes in the same way at social gatherings, to the coworker who delivers identical greetings each morning regardless of context, to the stranger at the coffee shop who orders the exact same beverage in the exact same manner every single day without ever attempting variation or spontaneity in their choices. What makes these instances particularly noteworthy is not simply that people develop habits, which is entirely normal and expected, but rather that they seem to exist in a state of apparent automaticity where genuine consciousness or present-moment awareness appears to be absent from their actions and words, as though they are running through dialogue trees and behavioral branches like characters in a video game environment. From a psychological perspective, this phenomenon can be understood through the lens of automaticity and habit formation, wherein the human brain becomes increasingly efficient at executing routine tasks by relegating them to unconscious processing, freeing up cognitive resources for other activities. And this process is so effective that people can navigate entire stretches of their days without conscious deliberation about their actions or choices. The brain's tendency to create these automated pathways is actually advantageous from an evolutionary standpoint, as it reduces mental fatigue and allows for rapid response to familiar situations without requiring the energy expenditure of conscious decision-making. Yet the side effect is that individuals can appear robotic or unaware when operating in these automated states. What truly invokes the uncanny sensation associated with NPC-like behavior is the complete absence of adaptation when context changes, the way certain individuals will respond identically to entirely different situations, offering the same solution to problems that require different approaches, or maintaining identical emotional expressions regardless of the actual emotional content of what they are experiencing or witnessing. There exists a phenomenon that occurs with such regularity in human experience that it has become normalized into the fabric of everyday life. Yet when examined closely, it defies rational explanation in ways that suggest either profound gaps in our understanding of perception or evidence of systematic anomalies in the structure of reality itself. These are moments when multiple unrelated individuals, separated by vast distances and without any possibility of communication, report nearly identical experiences, thoughts, or realizations at precisely the same moment, creating what might be described as synchronized consciousness across separate instances of human awareness. Mother in Tokyo suddenly thinks of calling her son at the exact moment he decides to contact her, their calls crossing in the ether as if guided by an invisible choreographer. Two strangers on opposite sides of the world sketch nearly identical symbols or write the same unusual phrase within seconds of each other, later discovering through social media that they had no mutual connections, no shared cultural references, nothing that would logically explain this convergence. These occurrences happen far more frequently than probability would suggest, yet we have developed sophisticated psychological frameworks to explain them away as coincidence, selective memory, or the inevitable mathematical outcome of billions of human minds operating simultaneously. The human brain is remarkably skilled at pattern recognition, and we are told this is sufficient explanation, that our minds are simply attuned to notice these connections while filtering out the millions of moments when such synchronicity does not occur. Yet this explanation, while logically sound, somehow fails to account for the persistent, almost uncanny frequency with which these events manifest, or the specific details that often accompany them, details that seem too precise, too elaborate to be mere chance. We have accepted these moments as quirks of consciousness, rather than investigating whether they might represent something more fundamental about the nature of reality itself, suggesting that what we call glitches in the matrix might be evidence of a system so vast and so intricately designed that certain moments of synchronicity are not failures but features, inherent patterns within the underlying structure that connects all human experience. Consider the experience of noticing the same numbers appearing repeatedly throughout your day, a phenomenon that has become so common in contemporary life that millions of people report it without hesitation or embarrassment. You glance at your phone and it reads 11:11, Then later that afternoon you receive a notification at 11:11 again. And when you check your email confirmation, it contains order number 11111. And as evening approaches, you find yourself looking at timestamps that consistently display patterns like 2:22 or 3:33, creating an undeniable sense that something intentional is occurring within the fabric of your reality. This experience transcends mere coincidence in the minds of those who encounter it repeatedly, as the statistical improbability of seeing the same numerical sequences across unrelated contexts and timestamps begins to accumulate into something that feels deliberately orchestrated rather than randomly distributed. The feeling intensifies when you realize that you're not simply noticing these numbers by accident, but rather that you seem to be drawn to check the time or look at screens precisely at moments when these patterns will appear, as though some invisible force is coordinating both the appearance of the numbers and your awareness of them simultaneously. From a psychological perspective, this phenomenon emerges from a mechanism called pattern recognition combined with selective attention and confirmation bias, where your brain becomes exceptionally skilled at identifying repeating sequences because such pattern recognition has been evolutionarily advantageous for survival. Yet this same mechanism causes you to notice 11:11 far more readily than 11:12, creating an illusion of impossible frequency, where in reality you're simply filtering the infinite stream of numerical data flowing through your environment each moment. The human mind operates as a prediction machine constantly seeking patterns and meaning, which means once you've noticed repeating numbers even once by genuine chance, your brain becomes primed to detect similar patterns in the future with enhanced sensitivity, essentially tuning your awareness like a radio receiver calibrated to a specific frequency. Consider the experience of thinking about someone you haven't spoken to in years, only to have them call you within the hour, or the peculiar phenomenon of seeing the same number repeated across different contexts throughout a single day, noticing it on a clock, a license plate, a receipt, and a street address all seemingly by chance. These moments of improbable timing and meaningful coincidence form what we might call synchronicity events, those instances where unrelated occurrences align in ways that feel far too intentional to be random, creating a sense that something beneath the surface of ordinary reality is orchestrating these encounters. People experience these events with remarkable consistency, describing moments where they arrive at a location only to encounter exactly the person they were about to contact, or where a song playing on the radio contains lyrics directly relevant to a problem they were just contemplating in silence. The intensity of these experiences often cannot be dismissed as mere chance, yet the mathematics of probability tells us that with billions of people and infinite daily interactions, some degree of meaningful coincidence becomes statistically inevitable. The human mind possesses an extraordinary capacity for pattern recognition, a survival mechanism honed over millennia that allows us to identify connections and relationships between disparate elements, sometimes even finding significance in randomness itself, a tendency psychologists refer to as apophenia. We are pattern-seeking creatures by nature, and when we encounter two or more events that align in time or meaning, our brains automatically construct narratives linking them together, creating a sense of meaning and purpose that may or may not actually exist in objective reality. Yet despite understanding this psychological mechanism, despite knowing that our brains are essentially prediction machines prone to finding patterns everywhere, people continue to experience synchronicity as something genuinely uncanny, something that feels different from ordinary coincidence. We have normalized this paradox, accepting simultaneously that these events are both explicable through psychology and genuinely mysterious, never quite resolving the tension between rational explanation and the undeniable felt experience of meaningful connection, as if the universe itself occasionally winks at us when we are not looking directly at it. Consider the phenomenon of encountering the number 1111 on digital clocks with an improbable frequency, a pattern so consistent that millions of individuals worldwide report noticing this specific time combination multiple times per week, sometimes even multiple times per day, far beyond what random chance would typically produce. The experience typically begins innocuously enough, with someone glancing at a clock at exactly 11:11 in the morning or evening, an observation that might ordinarily pass unnoticed, but instead becomes lodged in consciousness as a moment worthy of attention. From that point forward, the person finds themselves inexplicably drawn to check the time at precisely these 11:11 moments, discovering this alignment again and again across weeks, months, or even years of their daily existence. The occurrences accumulate in memory, while the countless other times they check their phone or watch and see different numbers fade into the background of forgotten moments, creating a cognitive illusion of impossible frequency. What makes this phenomenon particularly fascinating from a simulation theory perspective is the way it demonstrates how pattern recognition systems in human consciousness can create perceived anomalies from entirely ordinary statistical distributions. Yet the persistence of these reports suggests something deeper about the nature of attention itself and how consciousness selects which moments deserve to be remembered. The psychological mechanism underlying this phenomenon is known as frequency bias or the Baader-Meinhof effect, wherein once a pattern captures our attention, our brains become hyperalert to its recurrence, filtering reality through a lens that privileges confirmation while systematically ignoring all the disconfirming evidence that contradicts the perceived pattern. Every glance at a non-11:11 time is forgotten almost instantly, while the rare coincidence of seeing exactly 11:11 becomes crystallized in memory and attributed significance, reinforced by the emotional reaction of surprise or recognition that accompanies it. What remains striking about this particular glitch report is how it persists despite our collective understanding of probability and the mechanics of our own attention. How we continue to feel that subtle flutter of recognition and significance when we encounter this number combination, even as we consciously acknowledge the logical explanation for why it occurs. Consider the phenomenon of temporal recurrence, wherein individuals report experiencing the same sequence of events, conversations, or circumstances repeating across multiple days or weeks with such precision that the déjà vu sensation transforms into something far more unsettling and concrete. People describe arriving at work and having the exact same conversation with a colleague that they distinctly remember having yesterday, word for word, with the colleague showing no recognition of the previous interaction. Others report driving the same commute and encountering the identical traffic pattern, the same pedestrians in the same positions, the same songs playing on the radio in the same order, the same person ordering the same coffee at the same cafe at the same moment. Some individuals have documented these experiences, noting that they wore different clothes, lived through different evenings, yet somehow the morning repeated itself as though the day before had been reverted. The psychological explanation typically offered involves memory reconstruction and pattern recognition, suggesting that our brains naturally seek familiarity and may conflate similar events into a false sense of exact repetition. We are told that routine and habit create loops in perception, that commuting the same route makes each journey feel identical even when subtle variations exist, and that our minds are prone to filling gaps with expected outcomes rather than actual observations. However, what becomes peculiar is how frequently these accounts describe not merely similar feelings, but word-for-word dialogue, identical timestamps on clocks, the same coincidences occurring in sequence, patterns too specific to be explained by routine alone. Despite having logical frameworks to dismiss these experiences, despite the psychological explanations for pattern recognition and false memory, people continue to report these temporal anomalies with remarkable consistency across cultures and time periods. The accounts persist in journals, in forums, in conversations whispered late at night, and we have largely accepted them as quirks of consciousness rather than investigating whether something more systematic might be occurring within the structure of our experience itself. Perhaps what we resist acknowledging is that time loops might not represent a failure of our perception, but rather a glimpse into the repetitive mechanics that underlie reality itself, that consciousness, when sufficiently attuned, occasionally perceives the scaffolding beneath the illusion of linear progression, the places where existence resets and replays before we are meant to notice. Among the most unsettling reports within the simulation theory framework are documented cases of missing time, moments where individuals experience inexplicable gaps in their conscious experience, hours that seem to vanish from memory entirely, leaving behind only a vague sense of displacement and the troubling awareness that time has somehow been subtracted from their lives without explanation or recollection. These accounts span decades and cross cultural boundaries, manifesting in remarkably consistent patterns despite the geographical and temporal separation of those reporting them. suggesting either a shared psychological mechanism or something more fundamentally anomalous about how consciousness interacts with the passage of time itself. People describe beginning a drive home from work and suddenly finding themselves at their destination with no memory of the journey, no recollection of highway exits or turns, no awareness of how the minutes or hours accumulated, yet their fuel gauge reflects the distance traveled and their watches confirm the time has genuinely elapsed. Others report starting a conversation at a dinner table, looking away briefly, and then discovering that an entire evening has dissolved into absence, that family members have aged perceptibly in appearance, though only moments seem to pass in their own subjective experience, and that the calendar now shows dates weeks or months beyond where they remember leaving it. The psychological explanation offered by mainstream science typically invokes the concept of dissociation or highway hypnosis, a state where the brain operates on autopilot while attention becomes decoupled from active sensory processing, allowing memory encoding to fail despite normal motor function and environmental navigation continuing uninterrupted. This mechanism is real and documented, yet it fails to account for the profound qualitative difference that witnesses describe between missing time events and ordinary absent-mindedness, the specific sensation of discontinuity, the awareness that something has actively removed a segment of experience rather than their attention simply wavering. Consider the experience of recalling a significant event from your past, only to discover later through photographs, recordings, or conversations with others who were present that your memory of the event was fundamentally different from what actually occurred, and yet the false version feels just as vivid, just as emotionally resonant, and just as authentic as any other memory you possess. You remember the color of the sky on that day, the exact words someone said to you, the precise emotional tone of a moment, but when confronted with objective evidence, you discover that none of those details align with reality, and perhaps more disturbingly, you cannot even access the feeling of having believed the correct version before this moment of contradiction. Memory researchers call this phenomenon false memory, and they have spent decades documenting how remarkably easy it is to implant entirely fabricated experiences into a person's mind through suggestion, repetition, and the natural malleability of how our brains encode and retrieve information. Yet what remains unexplained is the seamlessness of these rewrites, the way the brain appears to not simply alter a memory, but to retroactively overwrite it so completely that the original version becomes inaccessible, almost as if it had never existed at all. Many people report the experience of remembering something with absolute certainty for years, telling the story repeatedly to friends and family, building an entire emotional narrative around this false recollection, only to have it suddenly corrected by external evidence. And what becomes eerie is that the person cannot recall the moment of correction integrating into their mind, cannot pinpoint when the false version was installed or when they began believing it with such certainty. From a biological standpoint, we understand that memories are not stored like files in a computer, but rather are reconstructed each time we recall them. And this reconstruction process is vulnerable to contamination from suggestion, emotion, and subsequent experiences. Yet the question that haunts this understanding is whether the feeling of remembering something is indistinguishable from the act of having actually experienced it, and whether consciousness has any reliable way to differentiate between a genuine memory and a perfectly constructed false one. We live in a culture now that has become almost normalized to the idea that our memories are unreliable, that we should not trust our own minds, and yet simultaneously we use these same unreliable memories to navigate every relationship, every decision, and every sense of identity we possess. Consider the phenomenon where multiple unrelated individuals report experiencing identical or nearly identical memories of events that never actually occurred, events that exist only in collective consciousness, yet feel vividly real to those who experienced them. One of the most documented examples involves the Mandela effect, named after the widespread false memory that Nelson Mandela died in prison during the 1980s, when in fact he was released and served as president of South Africa until his natural death in 2013. Countless people across different countries, different age groups, and different educational backgrounds hold vivid recollections of mourning his death decades earlier, of remembering news coverage and funeral broadcasts that simply do not exist in any historical record. Yet these memories are not vague or uncertain. They are accompanied by emotional resonance, by the sensation of knowing exactly where they were when they heard the news, what they were wearing, what the weather was like that day. Similar false memories exist regarding the spelling of well-known brand names, the exact wording of famous movie quotations, and the details of historical events that millions swear they remember differently than how they are documented. The psychological mechanism behind this phenomenon involves the constructive nature of human memory itself, which is not a recording device, but rather a reconstruction that relies heavily on suggestion, social reinforcement, and the power of narrative schemas. When one person confidently states a false detail, others listening may incorporate that detail into their own recollection through a process called source confusion, where the suggestion becomes indistinguishable from genuine memory. The more people who share and repeat a particular false version, the more credible and real it becomes in the collective mind. What makes this phenomenon particularly anomalous within the context of simulation theory is that these false memories do not simply occur randomly, but often cluster around specific details that feel deliberately planted, details that sometimes seem almost designed to test whether we notice inconsistencies in our shared reality. We have largely normalized this phenomenon by attributing it entirely to the fallibility of human cognition, yet the sheer scale and consistency with which millions of people hold identical false memories across different populations suggests something more systematically strange is occurring, a mechanism by which consensus reality itself might be subtly altered or reimplanted in human consciousness. Shadow people represent one of the most widely reported yet deeply peculiar phenomena within the broader landscape of unexplained experiences, characterized by the perception of dark humanoid figures that appear to move with intention and awareness, often glimpsed from the corner of one's eye or during states of altered consciousness such as sleep paralysis, drowsiness, or profound stress. These entities are described with remarkable consistency across cultures and centuries, appearing as silhouettes devoid of distinguishing features, sometimes possessing what observers interpret as a sense of presence or malevolent attention, and they vanish instantaneously when direct focus is attempted, leaving witnesses with an unsettling certainty that something genuinely occupied their visual field despite the complete absence of physical evidence. The phenomenon gained particular prominence in the late 20th and early 21st centuries through internet documentation and paranormal enthusiast communities. Yet historical accounts suggest that encounters with these shadowy presences predate modern technology, appearing in folklore, religious texts, and personal testimonies stretching back centuries across geographically isolated populations who had no shared cultural framework through which to interpret them. From a neurological and psychological perspective, shadow people sightings align remarkably well with the phenomenon of peripheral vision processing, wherein the rod cells that dominate the outer regions of human vision are extraordinarily sensitive to movement and darkness, but provide virtually no color or detail information, creating a situation where the brain must essentially hallucinate the missing details based on pattern recognition and expectation. A process that becomes particularly pronounced during sleep paralysis when conscious and unconscious states overlap, and the brain's threat detection systems operate at heightened sensitivity. Furthermore, the human pattern recognition system exhibits a well-documented tendency toward pareidolia, the interpretation of ambiguous stimuli as recognizable forms, which explains why shadows, peripheral movement, and darkened corners frequently resolve into human shapes within the observer's perception despite the absence of actual human-shaped objects, a tendency that becomes amplified during moments of fatigue, fear, or heightened emotional arousal when the prefrontal cortex's reality-testing capabilities are diminished. Throughout documented history and across nearly every culture, there exist recurring accounts of individuals encountering what appears to be an exact duplicate of themselves or someone they know, existing simultaneously in two separate locations, often with no rational explanation for how such a phenomenon could occur. These encounters typically follow a consistent pattern. A person reports seeing themselves walking down a street they are currently on, or a family member describes witnessing their relative performing actions in another room while that same person was verifiably present elsewhere, sometimes at a considerable distance away. The witnesses in these accounts are often credible individuals, including medical professionals, law enforcement officers, and academics, yet their testimonies remain largely dismissed by conventional science despite the prevalence and consistency of such reports across centuries and continents. One possibility for understanding these encounters involves the concept of recognition glitches within human consciousness itself, where the brain's facial recognition and identity verification systems momentarily misfire or become temporarily desynchronized, causing us to perceive a stranger's face as belonging to someone we know intimately, or creating a false sense of familiarity that feels unmistakably real in the moment. Additionally, the phenomenon might relate to brief temporal perception anomalies, where the brain fails to properly sequence events, causing a person who we saw only moments ago to appear to have traveled instantaneously to a new location where we encounter them again, creating the illusion of simultaneous presence. We have collectively normalized the dismissal of these accounts by attributing them entirely to misidentification, stress, fatigue, or the human tendency toward pareidolia, the same mechanism that causes us to see faces in inanimate objects. Yet what remains peculiar is how often these encounters happen to well-rested, observant individuals with no history of psychological disturbance, and how the consistency of these reports suggests something systematic rather than random, rather than purely the product of individual human error, a pattern that seems to persist despite our complete inability to explain it through conventional understanding. The Philadelphia experiment represents one of the most persistent urban legends in modern consciousness, a tale that emerged in the 1950s and continues to circulate through alternative communities and conspiracy forums with remarkable staying power, despite the complete absence of credible evidence. The story claims that on August 10, 1943, the United States Navy conducted a secret military experiment at the Philadelphia Naval Shipyard involving the destroyer escort USS Eldridge, during which the vessel allegedly became invisible and teleported instantly from Philadelphia to Norfolk, Virginia, a distance of roughly 270 miles, returning moments later with a crew experiencing severe psychological and physical trauma. The narrative suggests that electromagnetic field manipulation technology, supposedly derived from suppressed theoretical physics research, was weaponized to render military vessels undetectable to radar and human sight, creating an unprecedented tactical advantage during wartime that was subsequently covered up by military authorities who classified all documentation and silenced witnesses. The initial account came from a letter published in a science fiction magazine in 1956, attributed to a man claiming to be a supposed witness, though the identity and credibility of this individual were never established, and the USS Eldridge's actual records show the ship was in the Atlantic Ocean during the supposed incident, making the event physically impossible according to documented naval movements and logistical records. The psychological mechanism sustaining this belief operates through several interlocking cognitive patterns, beginning with the profound human desire to uncover hidden truths that powerful institutions allegedly conceal from public knowledge, a desire that becomes especially powerful when official denials seem suspiciously emphatic or when documentation appears conveniently unavailable. The story also taps into legitimate scientific uncertainty regarding theoretical physics and the public's limited understanding of electromagnetic phenomena, creating a credibility gap where advanced technology feels plausible enough to inspire belief while remaining sufficiently mysterious to resist easy debunking. The Montauk Point area in Long Island, New York, has accumulated a peculiar collection of historical incidents and environmental anomalies that have become woven into the fabric of simulation theory discussions and alternative historical narratives. Throughout the 1970s and 80s, various accounts emerged describing unusual electromagnetic phenomena, time displacement experiences, and strange military activity centered around the Montauk Air Force Station, a now decommissioned radar facility that once served as a critical defense installation during the Cold War era. Witnesses and researchers have reported experiencing missing time, unusual equipment malfunctions, electromagnetic interference affecting personal devices and vehicles, and even claims of temporal displacement where individuals allegedly experienced accelerated or reversed aging, suggesting possibilities that controlled experiments involving time manipulation or dimensional rifts may have been conducted within the classified facilities located there. The surrounding area has become notorious among simulation theorists who suggest that Montauk may represent a location where reality itself has been tested, manipulated, or fundamentally altered by unknown technological means, with electromagnetic anomalies potentially serving as evidence of systems interfacing with the fabric of consensus reality itself. The psychological mechanism supporting the persistence of Montauk anomalies operates through the combination of genuine Cold War military secrecy, which encouraged speculation about classified programs, coupled with the human tendency to cluster disparate experiences into coherent narratives that explain the inexplicable. When individuals experience missing time, equipment failures, or disorientation in specific geographic locations, the mind naturally seeks patterns and causes, and the presence of known military installations provides a ready explanation framework that feels satisfying even without definitive proof. Furthermore, the documented existence of actual military research into electromagnetic phenomena and theoretical physics during this historical period lends surface plausibility to more extraordinary claims, allowing speculation to flourish in the gap between confirmed history and complete verification. The Tartaria theory represents one of the most elaborate alternative historical narratives that has emerged from internet communities, proposing that a vast, technologically advanced civilization existed across Eurasia and was deliberately erased from historical records. According to this theory, Tartaria was a sophisticated empire that spanned enormous territories, possessed advanced architectural and engineering capabilities that modern societies struggle to replicate, and was suddenly removed from maps, textbooks, and collective memory through a coordinated effort by global powers who sought to suppress knowledge of this superior civilization. Proponents point to peculiar gaps in historical records, the sudden appearance of grand neoclassical buildings in the 18th and 19th centuries, and old maps that reference territories and place names no longer found in contemporary geography as evidence supporting this suppressed history. They argue that the architectural complexity of structures like cathedrals and governmental buildings could not have been constructed with the technologies supposedly available during their documented time periods, and that the style and sophistication suggest a more advanced predecessor civilization that created them. The theory proposes that major historical events, including various wars and social upheavals, were actually cover operations designed to erase Tartaria from existence and destroy evidence of its capabilities. Psychologically, this theory appeals to human pattern recognition systems and our tendency to seek hidden explanations for historical inconsistencies and architectural mysteries that we cannot easily explain through conventional narratives. The theory provides a coherent alternative framework that transforms confusing architectural anomalies and cartographic inconsistencies into evidence of a coherent suppressed history, which creates psychological satisfaction by offering certainty where official history appears to contain gaps. Furthermore, the theory taps into legitimate human skepticism toward institutional authority and documented history, converting reasonable questions about historical accuracy into validation for increasingly extraordinary claims. Imagine discovering that an entire stretch of recorded history might never have actually occurred, that somewhere between the 9th and 10th centuries, approximately 300 years were simply inserted into the timeline of human civilization without anyone noticing the insertion until centuries later. The phantom time hypothesis suggests that the early Middle Ages, a period traditionally dated from around 600 to 900 CE, may have been a fabrication, a block of time that never truly existed but was nonetheless woven into our historical fabric through a combination of clerical error, deliberate manipulation, and the gradual acceptance of falsified documentation across generations. What makes this hypothesis particularly intriguing is not that it has credible scholarly support, because it largely does not, but rather that it persists as a nagging question in the back of minds, a peculiar glitch in the architecture of recorded reality that refuses to be completely dismissed. The mechanism by which such a thing could theoretically occur rests upon the vulnerability of historical record-keeping during periods of societal fragmentation and limited communication, when individual monasteries and kingdoms maintained their own records with little cross-verification, when the copying of manuscripts by hand introduced opportunities for error and embellishment, and when the authority to declare something historical truth rested in the hands of remarkably few people with particular motivations and agendas. The hypothesis suggests that a combination of backdating documents, misinterpreting or reinterpreting existing records, and the simple human tendency to construct narratives that fill gaps in understanding could have created a phantom century or three that served various political and religious purposes for those in power. What persists despite the lack of rigorous evidence is the unsettling recognition that our historical record is fundamentally vulnerable to such manipulation, that the documents we depend upon to establish what actually happened could contain systematic errors so profound and so thoroughly normalized that they would be nearly invisible to detection, embedded so deeply in the fabric of accepted knowledge that questioning them feels like questioning the very ground beneath our feet, and this awareness, once introduced into consciousness, becomes difficult to entirely suppress. The dead internet theory proposes that the internet as we know it fundamentally changed sometime around 2016 or 2017, after which point the majority of online content ceased to be generated by authentic human beings and became instead the product of algorithmic systems, artificial intelligence, and coordinated networks of automated bots designed to simulate human interaction and engagement. According to this framework, what we experience as the living, breathing internet populated by millions of genuine voices has gradually been replaced by a sterile simulation where most comments, posts, videos, and interactions are generated by machine learning models trained to mimic human behavior with increasing sophistication, while real human voices have been either drowned out, algorithmically suppressed, or relegated to small enclaves of the digital landscape. The theory observes that modern internet culture has become remarkably homogeneous and repetitive, with identical jokes, memes, and talking points spreading across every platform simultaneously in ways that seem less organic than coordinated, where trending topics feel manufactured rather than emergent, and where genuine spontaneous human discourse has been replaced by predictable cycles of content that serves primarily to maximize engagement metrics and advertising revenue rather than foster authentic connection or exchange of ideas. What makes this theory psychologically compelling is that it provides a coherent explanation for the uncanny sensation many longtime internet users report experiencing when navigating contemporary digital spaces, a feeling that something fundamental has shifted in the quality and character of human presence online, that the internet has become increasingly sterile and simulation-like despite theoretical advances in technology that should have made connection richer and more authentic. The theory resonates because it acknowledges observable phenomena that persist in the collective consciousness of digital natives, the sense that comment sections read like algorithmic outputs, that social media interactions follow predictable patterns, and that the spontaneous weirdness and genuine human chaos that once characterized internet culture has been systematized and controlled into something more manageable and profitable for corporate interests. Consider the peculiar phenomenon where human beings appear to generate their own sense of self through a process of circular self-reference, a kind of existential bootstrap mechanism wherein consciousness seems to emerge from observing itself, creating an infinite regress that somehow resolves into the feeling of being a unified, coherent entity. In everyday experience, you become aware that you are aware, and from this recursive loop of self-awareness, the sensation of having a continuous identity gradually crystallizes, yet this process contains a fundamental logical impossibility that somehow functions anyway. When you think about your own thoughts, you create a strange loop where the observer and the observed become one and the same, generating what philosophers have termed a strange loop or tangled hierarchy. And yet your brain processes this recursive nightmare with such seamless efficiency that you never notice the logical violation occurring beneath the surface of your moment-to-moment experience. The mechanism appears to work through a combination of memory integration and narrative construction, where the brain takes disparate sensory inputs, emotional states, and past experiences, weaves them together into a coherent story, and then labels this story as you, as the unified subject doing the observing, even though the actual process involves thousands of distributed neural systems operating independently without any central control center pulling the strings. This bootstrapped consciousness persists because the brain has evolved remarkable systems for creating the illusion of unity, for stitching together fragmented processes into what feels like a seamless experience of being someone, of having a persistent self that remains fundamentally the same from one moment to the next. And this illusion functions so perfectly that most people never question whether the unified consciousness they experience actually exists, or whether it is instead an elaborate story the brain tells itself about itself. What becomes increasingly strange upon deeper reflection is that this bootstrap process appears to require no external validator, no outside observer to confirm that the self exists. And yet the self apparently exists anyway, arising spontaneously from the physical substrate of the brain, creating consciousness from the mere act of observing its own information processing. Pulling meaning and identity from the void through self-referential loops that should by all logical standards collapse into paradox, but somehow generate the rich, vibrant experience of being a person living a life. Consider the peculiar moment when you become acutely aware that your subjective experience is the only thing you can ever truly verify with absolute certainty, a realization that creeps into consciousness during moments of profound isolation or late-night introspection, and you find yourself genuinely unable to prove that anyone else possesses inner experience comparable to your own. That the people around you might be philosophical zombies, executing complex behavioral patterns without any accompanying consciousness whatsoever. This is not merely an abstract philosophical puzzle confined to academic discussions, but rather a genuine epistemological crisis that emerges naturally from the structure of human perception and knowledge itself. For you can never access another person's subjective experience directly, never feel their emotions through their nervous system, never see through their eyes in the way that you inhabit your own visual field. The mechanism underlying this persistent doubt operates through the fundamental asymmetry of consciousness, the way that your own mind is the only mind you experience from the inside, while all other minds remain forever external to your awareness, accessible only through indirect inference based on behavioral observation and language interpretation. You construct elaborate theories about other people's inner lives based on their words and actions, but these are fundamentally assumptions built upon pattern recognition rather than direct knowledge, and somewhere in the architecture of human reasoning, this logical gap between observation and inference never quite closes, leaving a hairline fracture of uncertainty that no amount of rational argument seems capable of sealing completely. What is remarkable is how persistently this doubt returns despite its apparent illogic, how even those who intellectually dismiss solipsism as absurd find themselves occasionally seized by the vertiginous feeling that they might be alone in a universe of unconscious automata, and how we have collectively normalized living with this unresolved uncertainty by simply agreeing not to examine it too closely. By accepting the practical necessity of treating others as conscious beings while remaining theoretically unable to prove that they are, thereby creating a strange compromise between what we know and what we can verify, between rationality and the structure of consciousness itself. Consider the peculiar phenomenon of lucid dreaming and the questions it raises about the nature of consciousness and reality itself. For within the dream state, the mind constructs entire universes complete with physics, weather systems, populated societies, and architectural spaces that feel entirely coherent and authentic in the moment of experiencing them. When you find yourself aware within a dream, conscious of the fact that you are dreaming while still remaining immersed in the dream environment, something remarkable occurs in the architecture of your perception, as the dreaming mind simultaneously generates the dream world, populates it with characters and scenarios, monitors your awareness of the dream, and maintains the illusion of an external reality all at once. This means that within your sleeping brain, a complete universe exists with apparent depth, continuity, and logical consistency, populated by what appear to be autonomous entities making decisions, yet all of it emerges from a single consciousness, a single biological system enclosed within a skull. The mechanism underlying this phenomenon relates to how the brain compartmentalizes information during REM sleep when the prefrontal cortex, responsible for critical evaluation, becomes less active while the visual cortex and emotional centers remain highly engaged, allowing the brain to generate elaborate narratives without the constant reality checking that occurs during waking hours. Yet what persists most unnervingly is the question of whether the dream universe is truly less real than waking consciousness, because if consciousness itself generates both, and if the dreaming mind can convince itself so thoroughly of an alternative reality complete with physical laws and social structures, then the distinction between simulation and reality becomes fundamentally unclear. We have largely normalized this by treating dreams as mere neural noise, as byproducts of sleep rather than as evidence that consciousness is capable of creating entirely convincing realities from within itself, and we move through our waking lives without truly confronting the implications that if our brain can fool us so completely during sleep, what guarantees exist that our waking perception operates any differently? What prevents the entire waking experience from being a more elaborate, longer duration dream from which we have simply not yet become lucidly aware? The Hindu concept of Maya presents one of the most philosophically sophisticated frameworks for understanding reality as fundamentally illusory, a doctrine that has persisted across centuries and continues to shape how billions of people interpret their experience of existence. In the classical Hindu philosophical tradition, particularly within Advaita Vedanta, Maya refers not to simple magic or tricks, but rather to the cosmic illusion through which the infinite, undifferentiated Brahman or ultimate reality appears to manifest as a multiplicity of distinct forms, individual consciousnesses, and a material universe governed by apparent laws of causality and separation. The doctrine suggests that what we perceive as objective reality, with its seemingly solid objects, distinct subjects and objects, the flow of linear time, and the fundamental separation between observer and observed, is actually a veil or projection cast over a unified, non-dual substrate of pure consciousness that transcends all these apparent distinctions. What makes this particularly relevant to simulation theory discourse is how the doctrine functions as a sophisticated philosophical model for understanding consciousness, reality, and the nature of perception itself, proposing mechanisms through which an infinite singular awareness could generate the appearance of a finite, fragmented, materially bound universe without that universe actually being fundamentally real in any absolute sense. The psychological mechanism supporting this doctrine operates through a recognition that our perception of reality is necessarily filtered through the limitations of sensory apparatus, conceptual frameworks, and the inherent subject-object duality that consciousness imposes upon experience, much in the way that a computational system must render infinite data through finite processing substrates and display parameters. The doctrine persists because it addresses fundamental philosophical puzzles about consciousness, continuity, and the nature of existence that remain unresolved by materialist frameworks, and because it offers practitioners a coherent interpretive model for reconciling the apparent multiplicity of experience with underlying philosophical intuitions about the unity and interconnectedness of all phenomena. Consider the ancient Hindu philosophical concept of Brahman, the infinite, eternal, unchanging ultimate reality that underlies all existence, and how this framework suggests that consciousness itself is the primary substance of the universe rather than matter being fundamental and consciousness emerging from it as a secondary effect. According to this metaphysical tradition, all of reality as we perceive it, including our individual identities, our physical bodies, the entire material cosmos with its galaxies and atoms and laws of physics, exists as nothing more than the dream or imagination of Brahman in a state of cosmic consciousness, comparable to how a dreamer generates an entire world of experience while asleep in their bed with their eyes closed. The observable universe with its intricate complexity, its mathematical precision, its apparent independence from our minds, and its convincing solidity when we interact with it through our sensory organs, might itself be a manifestation of divine consciousness exploring itself through infinite perspectives and experiences. When we examine this concept through the lens of simulation theory and the anomalies that plague our understanding of physical reality, the parallels become remarkably striking and difficult to dismiss as mere coincidence or poetic metaphor. Our modern physics has revealed that matter at its fundamental level behaves differently depending on whether it is observed, that particles exist in superposition until measured, that time itself appears flexible and relative rather than absolute, and that consciousness seems to play an inexplicable role in collapsing quantum possibilities into singular outcomes. These discoveries fundamentally challenge our intuition about an objective external world existing independent of perception, pushing us instead toward the recognition that observation and consciousness are woven into the very fabric of reality's functioning. The Brahman concept proposes exactly this relationship, suggesting that apparent discontinuities in our reality, the strange behaviors of quantum systems, the inexplicable fine-tuning of universal constants that allows life to exist, and the persistent feeling that something is fundamentally off about existence itself, all point toward the truth that we are experiencing a conscious entity's dream rather than an independently existing material universe. Consider the modern phenomenon of algorithmic curation, where billions of individuals spend hours each day observing carefully filtered representations of reality that have been shaped by invisible computational processes designed to maximize engagement and prediction accuracy. A situation that bears striking resemblance to Plato's ancient allegory of the cave, except the prisoners are now willing participants who have voluntarily positioned themselves before digital screens. Watching shadows cast by a fire they cannot see, generated by algorithms optimizing for metrics they do not understand. The prisoners in Plato's original cave were chained and could only observe shadows on a wall, unable to turn their heads or question the nature of their confinement. But today's version presents a curious inversion where the chains are psychological rather than physical, maintained by habit, social obligation, the fear of missing cultural moments, and the genuine pleasure derived from the stimulation itself. The mechanism underlying this modern cave involves a feedback loop where our attention is captured by content that triggers emotional responses, whether those responses are outrage, joy, fear, or belonging, and the algorithms learn which types of shadows produce the strongest reactions, then prioritize showing us more variations of those particular shadows, gradually narrowing the range of reality we encounter while simultaneously creating the illusion of expansive choice and unlimited information access. What makes this situation particularly anomalous is our collective awareness that this is occurring. Yet our continued participation in the system, despite possessing intellectual understanding that our perception of reality has been systematically filtered, curated, and algorithmically optimized without our explicit consent or full comprehension of the mechanisms involved. We have normalized the idea that our understanding of current events, cultural trends, scientific developments, and social movements is mediated through systems designed primarily for profit extraction rather than truth discovery. And we often reference this knowledge casually while remaining essentially unable to extract ourselves from the cave, trapped not by external force, but by the architecture of modern life itself, the social requirement to maintain digital presence. The legitimate value of information sharing platforms, and the uncomfortable truth that stepping away from the shadows means stepping away from connection to the broader social organism. In the early 17th century, the philosopher René Descartes proposed a thought experiment designed to test the limits of what we could truly know with certainty. Imagining a powerful demon capable of deceiving him about every single aspect of his perceived reality, from the simplest mathematical truths to the most fundamental sensations of his own body. What makes this classical philosophical exercise relevant to the modern experience of simulation theory anomalies is how often we encounter moments in our daily lives where the boundary between authentic perception and potential manipulation becomes genuinely unclear, where the question of what is real versus what might be carefully constructed for our consumption takes on a peculiar urgency. Consider the proliferation of deepfakes, artificial intelligence-generated content, and the sophisticated algorithms that shape what information appears on our screens, creating a landscape where visual evidence itself has become unreliable, where a video of something occurring might be entirely synthetic, indistinguishable from documentation of actual events. The psychological mechanism underlying this modern resurrection of Descartes' demon lies in the fact that we have constructed technological systems designed explicitly to simulate reality, to predict our behavior, to optimize what we see and believe. And in doing so, we have created the infrastructure for a demon that does not require supernatural power, but merely operates according to the logic of profit and engagement. What is particularly unsettling about the contemporary version of Descartes' problem is not merely that deception is theoretically possible, but rather that we now live within systems explicitly designed to influence our perception while maintaining plausible deniability about the extent of that influence, and despite being intellectually aware of this dynamic. We continue to navigate our information environments as though they were transparent windows onto reality rather than carefully curated simulations. The normalization of this state of affairs represents perhaps the most significant shift in human consciousness in recent decades, a collective agreement to proceed as if we have certainty when we have increasingly less of it, to trust our perceptions when those perceptions are demonstrably shaped by algorithms optimizing for engagement rather than truth, and to accept that we may never truly know the extent to which the reality we experience has been filtered through countless layers of mediation and manipulation. Consider the philosophical proposition that has haunted consciousness studies for decades: the possibility that your entire experienced reality every sensation, emotion, and memory could be nothing more than the electrical stimulation of a disembodied brain suspended in a vat of nutrient solution, receiving perfectly orchestrated signals from an external computer system that generates the complete illusion of a coherent world around you. In this scenario, you would have no way whatsoever of detecting the deception, because the signals reaching your neural tissue would be indistinguishable from those produced by genuine sensory organs interacting with a physical environment. And every thought you have about this possibility, every doubt you entertain, every logical argument you construct to refute it, would itself be part of the simulation, potentially planted there deliberately to keep you from ever discovering the truth of your actual condition. The mechanism that makes this thought experiment so psychologically destabilizing rests upon a fundamental vulnerability in human consciousness: our complete dependence on the signals our brains receive rather than on direct access to external reality itself. We do not actually perceive the world. We perceive only the neural representation of the world constructed by our sensory processing systems. And since these representations could theoretically be generated by any sufficiently complex source, including artificial stimulation, there exists an unbridgeable epistemic gap between what we experience and what actually exists. What makes this anomaly particularly unsettling is not merely its logical coherence, but the way we have normalized our epistemic imprisonment despite its profound implications, continuing to make decisions, form relationships, and assign meaning to experiences while acknowledging that we cannot definitively prove these experiences correspond to anything external at all. We live our entire lives accepting this uncertainty without faltering, moving through our days as though we have certainty when we possess none, and this cognitive dissonance between our intuitive confidence in external reality and our rational acknowledgement of our inability to prove it persists unchallenged in the background of our consciousness, a glitch in the logical foundation of how we construct meaning that we have learned to simply ignore. Yet perhaps this very acceptance represents our greatest achievement: the capacity to build knowledge, love, and purpose upon foundations we cannot fully verify, transforming an epistemological abyss into the scaffolding of meaningful existence. Consider the philosophical puzzle known as the Boltzmann brain, a thought experiment emerging from Ludwig Boltzmann's work on statistical mechanics and entropy, which suggests that in an infinitely old universe trending toward maximum entropy, random quantum fluctuations could theoretically assemble a conscious observer spontaneously from the void, a brain materializing complete with false memories and sensory impressions, existing for only moments before dissolving back into chaos. And what becomes deeply unsettling is that if such a scenario is mathematically possible, then statistically speaking, the majority of conscious observers in an infinite universe would be these temporary Boltzmann brains rather than beings like us embedded in stable, ordered worlds with coherent histories and continuous existence. The mechanism underlying this anomaly operates through a simple but terrifying logical chain. If given infinite time and infinite space, any possible configuration of matter, no matter how improbable, will eventually occur through random chance. And since a localized brain with false memories requires fewer total fluctuations than an entire universe with galaxies and stars and evolutionary history, these phantom minds should vastly outnumber genuine observers in any probabilistic accounting of consciousness. Yet we persist in assuming we are not Boltzmann brains, that our memories are real, that causality flows backward from past to present in meaningful ways, that we exist within an ordered cosmos rather than as momentary hallucinations of entropy itself. And this assumption goes largely unexamined in daily life, treated as obviously true despite the mathematical arguments suggesting otherwise. What makes this anomaly particularly persistent is that there exists no empirical test capable of distinguishing between being a genuine conscious entity with real memories and being a Boltzmann brain with false ones, creating a perfect philosophical trap where the very structure of consciousness prevents us from verifying our own authenticity, and so we continue operating under the assumption of our own realness. Building civilizations and making plans and forming relationships as though our continued existence is assured, even though the universe's tendency toward disorder suggests we should be temporary fluctuations rather than persistent beings. And this tension between what probability suggests and what we must assume to function creates an underlying dissonance in the logical structure of reality itself. Consider the precise mathematical constants that govern the structure of reality itself, those fundamental values embedded within the fabric of physics that determine everything from the strength of gravity to the behavior of light, and observe how extraordinarily narrow the range of acceptable values appears to be for the universe to function as it does. If the gravitational constant were slightly stronger, all stars would have burned out long before complex life could emerge, and if it were marginally weaker, stars would never have formed in the first place, leaving only diffuse hydrogen clouds drifting through an eternal void. The same precarious balance applies to the cosmological constant, to the ratio of matter to energy, to the strength of electromagnetic force relative to the nuclear forces, to the mass difference between protons and neutrons, to the precise value of dark energy, each one a dial that appears to have been set to an impossibly exact specification. The probability calculations that physicists have performed suggest that the likelihood of these constants aligning so perfectly by mere chance approaches the infinitesimal, numbers so small they exist in the realm of pure abstraction rather than practical comprehension. The psychological mechanism at work involves a profound tension between our intuitive sense of cosmic randomness and the unavoidable observation that we inhabit a universe with the precise characteristics necessary for our own existence, creating what is sometimes called the fine-tuning problem or the anthropic principle, a conceptual puzzle that our minds struggle to reconcile. We have normalized the existence of this coincidence through several interpretive frameworks, some invoking the multiverse hypothesis where countless universes exist with varying constants, making our universe merely the inevitable observer selection among infinite possibilities, while others suggest that consciousness itself might be somehow woven into the fundamental equations, or that we have simply misunderstood the deeper symmetries and mathematical laws that would render these constants less improbable than they appear. Yet the disquieting quality of this phenomenon persists despite these intellectual accommodations, because deep within our contemplation of this arrangement lies an unresolved question about whether we are discovering objective properties of reality, or whether we are simply describing the necessary preconditions for our own existence in a manner that will always seem inevitable from inside the system. Consider the peculiar observation that we exist in a universe with physical constants precisely calibrated to allow for consciousness itself, a phenomenon known as the anthropic principle, which suggests that we observe the universe to be compatible with conscious life because we are conscious observers within it. Yet this circular reasoning reveals something deeply unsettling about reality that we have largely normalized into philosophical acceptance, rather than treating it as the genuine anomaly it represents. The anthropic principle emerges when we examine the fundamental constants of physics, the strength of gravity, the electromagnetic force, the mass of electrons, the density of dark matter, and discover that if any of these values were altered by even the smallest fraction of a percentage, stars would never form, planets would never coalesce, chemistry would become impossible, and consciousness would be forever barred from existing anywhere in the observable universe. We find ourselves in one of an incomprehensibly vast number of theoretically possible universes, or in a universe governed by one specific set of constants among infinite theoretical possibilities, yet here we are, asking why our existence is possible at all. The mechanism behind this reasoning is straightforward yet deeply troubling. We can only observe universes in which we are able to exist, meaning any universe in which we find ourselves necessarily contains the conditions required for our consciousness, creating a tautological loop that explains nothing yet feels like profound truth. We have accepted this principle as a reasonable explanation without acknowledging what it truly represents, either an impossible coincidence of staggering magnitude, evidence of purposeful design by some unknown intelligence, or a multiverse so vast that consciousness emerges somewhere within it statistically inevitably. Yet we have normalized this cosmic mystery into academic discussion, treating the apparent fine-tuning of reality as merely an interesting philosophical puzzle rather than a fundamental glitch in the fabric of logical causality, as if probability itself has bent backward to ensure our observation of existence, suggesting that perhaps consciousness does not arise from the universe, but rather the universe is arranged specifically so that consciousness might emerge to witness it. The cosmological constant problem represents one of the most profound and unsettling inconsistencies in modern physics, a gap so vast that it has been described as the worst theoretical prediction ever made in the history of science. When physicists attempt to calculate the energy density of the vacuum, the seemingly empty space that permeates the entire universe, their quantum field theory equations produce a number that is approximately 120 orders of magnitude larger than what we actually observe in reality. This means that if the theoretical prediction were correct, the universe should have expanded so catastrophically fast in the moments following the Big Bang that no stars, planets, or life could have ever formed. Yet here we are, observing a cosmos that expanded at a measured and deliberate pace, one that allowed for the eventual emergence of galaxies and conscious observers. The observed accelerating expansion of the universe, discovered in 1998 through observations of distant supernovae, does require some form of dark energy with properties similar to what a cosmological constant would provide. Yet the magnitude of this required energy is wildly different from what quantum mechanics predicts, creating a chasm of incomprehension between our two most successful theories of reality. The psychological mechanism that allows this problem to persist in the scientific community involves a kind of compartmentalization, where physicists have learned to work within their respective frameworks without forcing a direct confrontation with this fundamental incompatibility. We have normalized the existence of this gap by treating it as merely another unsolved problem awaiting future breakthroughs, rather than recognizing it as potential evidence that something may be fundamentally wrong with our entire approach to understanding reality at the deepest levels. The universe seems to operate according to rules that our current mathematical frameworks cannot adequately describe, yet we continue forward, adjusting our models and introducing new concepts like dark energy without fully resolving why such enormous discrepancies exist in the first place. Consider the observable universe as we measure it today, and you will encounter one of the deepest puzzles in cosmology, a problem so fundamental that it demands explanation yet remains almost invisible in our daily consciousness. The universe, according to our measurements, appears to be geometrically flat. When cosmologists observe the cosmic microwave background radiation, those ancient photons that have traveled for nearly 13.8 billion years to reach our instruments, they find that the geometry of spacetime itself follows what mathematicians call Euclidean geometry, the same geometry you learned in school where parallel lines never meet and the angles of a triangle always sum to 180 degrees. This flatness is measured with extraordinary precision, deviating from perfect flatness by less than 1% according to our most sensitive observations, and this is where the puzzle deepens. In the early universe, just fractions of a second after the Big Bang, if the expansion rate had been even infinitesimally different, the universe would have either collapsed back on itself or expanded so rapidly that no galaxies, stars, or planets could ever form. The probability that the universe emerged with precisely the right density to achieve this flatness is staggeringly small, comparable to throwing a dart across the entire observable universe and hitting a target the size of a single atom. Yet here we are, existing in a universe that appears almost perfectly balanced on this knife edge of geometric equilibrium. Our minds accept this through a process of habituation and abstraction, wherein we transform an almost incomprehensibly improbable coincidence into a mere technical detail, a parameter to be plugged into equations rather than a profound mystery worthy of wonder. We have normalized the impossible by encoding it into our cosmological models, treating the flatness as simply one more measurement to record, one more number in the grand ledger of physical constants. This cognitive mechanism allows us to function without being paralyzed by the sheer implausibility of our existence. Yet the flatness problem persists at the deepest level of reality, a glitch in the fabric of probability that we encounter whenever we truly pause to contemplate what it means that the universe is fine-tuned to this extraordinary degree. Imagine standing at the edge of a vast landscape and looking toward the distant horizon, where the Earth appears to meet the sky in a perfectly flat line that stretches equally in all directions around you, creating what our perception insists is a fundamental truth about the shape of the world beneath our feet. This phenomenon, known as the horizon problem, describes a peculiar inconsistency in how we perceive the curvature of the Earth and our place within a universe that is demonstrably spherical. Yet our immediate sensory experience consistently contradicts this knowledge. When you look out across a landscape, no matter how high you stand or how clear the day might be, your eye cannot detect the curvature that we know exists, and instead perceives a horizon that appears flat, receding uniformly into the distance as though you were standing on an infinite plane rather than the curved surface of a sphere. The horizon problem becomes more intriguing when we consider that this visual deception persists even with our modern understanding of astronomy and physics, even though we have seen photographs of Earth from space that undeniably show its spherical nature. The mechanism behind this perception relates to the sheer scale of the Earth relative to our position upon it, combined with the limitations of human vision and the way our brains construct spatial understanding from visual information. The curvature of Earth is so gradual from our perspective that the angle of incline at the horizon remains beneath the threshold of human visual detection, and our pattern recognition systems default to interpreting a flat plane because that is what our local environment most closely resembles. What makes this anomaly particularly striking from a simulation theory perspective is that the horizon problem reveals a kind of rendering inconsistency, a gap between what we empirically know to be true about the world and what we directly perceive from our limited vantage point. We have normalized this disconnect entirely, accepting that our senses deceive us in this fundamental way, and that this deception is simply a natural consequence of human scale and planetary size. Yet the fact remains that reality and perception operate on entirely different registers without triggering deeper questions about the nature of our observational framework. Throughout human history, observers have noted that certain geometric and mathematical patterns appear repeatedly across vastly different scales of the universe, from the microscopic realm of atoms to the largest structures of galaxies, and this phenomenon has been termed the fractal or recursive nature of cosmic organization. When we examine a spiral galaxy rotating through the void of space, we see the same logarithmic spiral that appears in the Nautilus shell, in hurricanes on Earth, in the unfurling of fern fronds, and in the arrangement of seeds within a sunflower, suggesting either a profound universal principle or an inexplicable coincidence repeated across incompatible domains. The Fibonacci sequence materializes everywhere we look with attention, from the branching of trees to the arrangement of leaves, from the proportions of the human face to the structure of DNA molecules. And while mathematicians and biologists offer explanations rooted in efficiency and optimization, the sheer persistence of these identical patterns across unrelated evolutionary paths remains philosophically unsettling. Hexagons appear in honeycomb structures created by bees with no knowledge of geometry, in the columnar basalt formations of volcanic regions, in the atmospheric storms of gas giants, and in the cellular structures of countless organisms, yet each instance emerged independently without shared instruction or communication. When we observe that the distribution of matter in the cosmic web mirrors the structure of neural networks in brains, or that river systems branch in patterns identical to blood vessel networks and lightning strikes, we confront the possibility that reality itself operates from a limited set of templates or blueprints that exist independent of the systems expressing them. The mechanisms explaining individual instances seem logical enough when examined in isolation, whether through natural selection, physical laws governing fluid dynamics, or mathematical principles of structural stability, yet the totality of this recursive patterning across incompatible systems suggests something deeper than mere coincidence or convergent solution finding. We have largely normalized this phenomenon by compartmentalizing it into separate disciplines, allowing physicists, biologists, and mathematicians to study identical patterns without necessarily acknowledging their shared nature or wondering why the universe would iterate the same designs across contexts that should have no connection whatsoever. Consider the peculiar mathematical consistency found throughout the natural world, where patterns repeat themselves at every scale of observation, creating an infinite regression of self-similar structures that seem to follow precise mathematical rules without any apparent mechanism enforcing them. When you examine a fern frond, you notice that each individual leaflet mirrors the overall structure of the entire frond, and this same branching pattern appears in river systems, lightning bolts, blood vessels, bronchial tubes, and tree branches across countless species and environments. The coastline of a continent exhibits the same jagged complexity, whether viewed from space or magnified to examine a single rocky outcrop, and this recursive quality persists no matter how much you enlarge or reduce your perspective. Snowflakes form elaborate hexagonal structures with infinitely intricate details that repeat and mirror themselves in patterns that seem mathematically predetermined, Yet each snowflake forms individually in clouds with no apparent communication or shared blueprint, with other snowflakes forming simultaneously. The branching patterns of neural networks in the brain mirror the branching patterns of river deltas, which mirror the branching patterns of trees, which mirror the patterns of crack formations in drying mud, suggesting some fundamental principle organizing matter and energy across radically different physical systems and scales of magnitude. This self-similarity is so consistent and mathematically elegant that it appears almost algorithmic, as though nature were operating from a repeating program or template that generates complexity through recursive iteration. The human brain, having evolved within this fractally organized universe, demonstrates fractal properties in its own structure, suggesting we are pattern-matching systems designed to navigate and inhabit a fractal reality. Yet we have largely normalized this extraordinary consistency as merely a curiosity of mathematics, a feature we call fractal geometry that we study and catalog without fully addressing the deeper question of why physical reality should exhibit such precision and mathematical beauty at every scale. The question of whether fractals represent fundamental architectural principles of the simulation itself, or whether they indicate an underlying conscious ordering principle shaping matter and energy into these recursive patterns, remains unexamined in mainstream discourse, buried beneath layers of accepted scientific explanation that describe the phenomenon without explaining its origin or mechanism. Consider the peculiar prevalence of the golden ratio, that mathematical constant approximately equal to 1.618, which appears with striking regularity throughout nature, architecture, and human design in ways that seem far too consistent to be coincidental. The human eye encounters this proportion in the spiral of a nautilus shell, in the arrangement of sunflower seeds, in the branching patterns of trees, in the proportions of the human face and body, and increasingly in the designs of modern technology interfaces, furniture, and artistic compositions. Architects from the ancient Greeks to contemporary designers have incorporated these proportions into their work, claiming that structures built according to this ratio possess an inherent aesthetic harmony that resonates with human perception. Yet when we examine this phenomenon more closely, a curious cognitive mechanism emerges. We have become extraordinarily skilled at recognizing patterns that conform to our expectations, while simultaneously overlooking or dismissing instances where the ratio does not appear as prominently as we might anticipate. The golden ratio has become so culturally embedded in our understanding of beauty and proportion that we unconsciously seek it out, finding it in contexts where it may only approximately exist, or where our eyes have been trained by years of exposure to perceive it as present. Scientists and mathematicians have long debated whether the golden ratio truly appears in nature with the frequency we claim, or whether our pattern recognition systems have become so sensitized to this particular proportion that we habitually emphasize examples that fit while mentally filtering out those that do not. What remains genuinely unsettling is that despite rigorous analysis questioning the universality of this ratio, we continue to design with it, market products using it, and educate people about its importance without substantial interrogation. The simulation hypothesis would suggest that the ubiquity of the golden ratio represents either an efficient algorithm for generating aesthetically pleasing structures, or a deliberate watermark of intentional design embedded throughout the world we perceive, a mathematical signature repeating endlessly as if to suggest that nothing here has truly emerged organically. Perhaps most troublingly, we rarely pause to consider whether our obsession with finding the golden ratio has become a self-fulfilling prophecy, a collective agreement to see mathematical perfection in a universe that may be far more random and chaotic than our pattern-seeking minds can comfortably accept. Consider the spiraling arrangement of seeds within a sunflower head, or the branching pattern of a tree as it grows upward and outward into the sky, or the curling of a fern frond as it unfurls from its tight coil, or the spiral chambers of a nautilus shell, or the pattern of scales on a pinecone, or the way petals arrange themselves on a flower, or how leaves distribute themselves along a stem to maximize exposure to sunlight. In each of these biological systems, a mathematical sequence emerges with remarkable consistency, a sequence known as the Fibonacci sequence, where each number is the sum of the two preceding ones. 0, 1, 1, 2, 3, 5, 8, 13, 21, 34, 55, and so forth into infinity. When you examine a daisy, you will often find 55 petals, or 89, or 144, all Fibonacci numbers. Sunflower seed spirals typically exhibit either 21 spirals in one direction and 34 in the other, or 34 and 55, or 55 and 89, all consecutive Fibonacci pairs. Pine cones display spirals ascending in one direction and descending in another, consistently following Fibonacci ratios. The branching of trees, the arrangement of leaves along stems, the structure of human lungs and arterial systems, even the spiral of our own DNA molecule, all seem to conform to this mathematical pattern. The deeper question emerges when we contemplate why this sequence, discovered as a mathematical abstraction by Leonardo Fibonacci in the 13th century while observing rabbit populations, should manifest so ubiquitously throughout the natural world. The answer lies in optimization and efficiency. Fibonacci spirals represent the most economically efficient packing arrangement for growing organisms, allowing maximum exposure to resources like sunlight or water while minimizing overlap and wasted space. Natural selection has produced countless organisms that follow this pattern not because they consciously calculate mathematics, but because organisms that grew in these proportions possessed survival advantages over those that did not. Yet despite understanding the evolutionary logic behind these patterns, we find ourselves in a peculiar state of cognitive dissonance, where the appearance of this abstract mathematical sequence in nature still strikes us as profoundly uncanny, as if the universe itself is encoded with human mathematical understanding, when in reality the mathematics emerged from observation of nature itself. Consider the peculiar position in which mathematics exists within our understanding of the universe, functioning simultaneously as both a tool we invented and an absolute description of how reality actually operates, a distinction that becomes increasingly blurred the deeper we examine it. When physicists describe the behavior of subatomic particles or the curvature of spacetime, they do so almost entirely through mathematical equations, yet these equations consistently predict phenomena with startling precision, suggesting that mathematics is not merely a language we have created to describe nature, but rather the fundamental substrate of existence itself. We observe that pi appears in the ratio of circles regardless of whether anyone is observing them, that the Fibonacci sequence manifests in spiral galaxies and in the arrangement of seeds within a sunflower, that prime numbers distribute themselves according to statistical laws that seem to operate independently of human awareness or measurement. The strangeness intensifies when we consider that mathematics exists in a realm that appears to transcend physical space entirely, yet its abstract patterns manifest in concrete physical reality with such consistency that we have built entire civilizations upon mathematical principles, from architecture to engineering to economics, operating as though mathematics were the instruction set by which the universe executes itself. What becomes psychologically peculiar is how we have normalized this situation, treating it as obvious that abstract symbols and logical relationships should have any bearing whatsoever on the physical world, when this is fundamentally mysterious and counterintuitive. We have grown so accustomed to the effectiveness of mathematics that we rarely pause to consider how extraordinary it is that the contents of human minds, patterns of thought that exist nowhere in the natural world until we consciously construct them, should correspond so perfectly to the hidden architecture of reality itself. The mechanism underlying this normalcy appears to be a form of existential habituation, wherein we encounter the miraculous so consistently that we cease to recognize it as miraculous at all, treating the unreasonable effectiveness of mathematics as merely the way things are meant to be rather than as a profound anomaly suggesting that our reality operates according to principles that transcend our conventional understanding of how information, consciousness, and physical matter ought to relate to one another. Conway's game of life is a cellular automaton devised in 1970 by mathematician John Horton Conway, and it operates according to remarkably simple rules that govern how individual cells on a grid either live, die, or reproduce, based solely on the number of neighbors they possess in each generation. The system begins with an initial configuration of live cells scattered across an infinite two-dimensional grid, and from that point forward, time progresses in discrete steps where each cell's fate in the next generation is determined entirely by counting how many of its 8 adjacent neighbors are currently alive, with a live cell surviving if it has 2 or 3 neighbors, a dead cell becoming alive if it has exactly 3 neighbors, and all other cells either dying from isolation or overcrowding. What makes this system particularly striking as a potential glitch indicator is that despite its absolute determinism and the absence of any hidden variables or external influence, Conway's game of life produces emergent patterns of startling complexity, including stable structures that never change, oscillators that repeat in predictable cycles, and most unnervingly, spaceships that appear to move across the grid as though they possess agency and direction, despite being nothing more than the inevitable mathematical consequence of applying the same four basic rules repeatedly to every cell simultaneously. The psychological mechanism underlying our fascination with this anomaly is rooted in pattern recognition and our instinctive attribution of purpose to systems that display organized behavior, because our brains evolved to detect meaningful patterns in nature and to assume that complexity implies intention. Yet Conway's game of life violates this intuition by demonstrating that intricate, seemingly purposeful behavior can emerge entirely from simple mechanics with no designer, no goal, and no consciousness whatsoever. We have normalized the existence of game of life by compartmentalizing it as mathematics, a domain we accept as separate from physical reality. Yet this segregation itself deserves scrutiny, because if our universe operates according to similarly simple fundamental rules layered into incomprehensible complexity, how would we distinguish between a simulation governed by basic algorithms and a universe operating according to what we call the laws of physics, when both would produce the same observed emergent properties and the same sense of inexplicable order arising from simplicity? Consider the observation that systems throughout our reality tend to develop elaborate structures and behaviors that appear to exceed the complexity of their foundational components, a phenomenon known as emergent complexity, where simple rules and interactions somehow generate intricate patterns, consciousness, culture, and organization that seem to transcend their underlying mechanics in ways that remain fundamentally difficult to fully explain or predict despite centuries of scientific inquiry. When we examine ant colonies, we find thousands of individual insects operating from relatively basic chemical signals and local interactions, yet collectively they construct multi-level architecture, wage strategic warfare, farm fungus, and adapt to environmental changes with a sophistication that suggests a unified intelligence directing the whole, even though no ant possesses awareness of the colony's overall objectives or structure. Similarly, consciousness itself emerges from neurons, individual cells firing in patterns of electrochemical impulses, and yet from billions of these simple firing events arises subjective experience, self-awareness, creativity, and the ability to contemplate existence itself, a leap in organizational sophistication that our current neuroscience acknowledges but cannot fully bridge conceptually. In human societies, cultural norms and economic systems arise from countless individual decisions and interactions, creating intricate social structures, artistic traditions, technological advancement, and institutional frameworks of staggering complexity that no single person designed or fully understands, yet which operate with enough coherence to persist across generations and continents. The psychological mechanism enabling our acceptance of emergent complexity involves our tendency to compartmentalize understanding, treating high-level phenomena as sufficiently explained by invoking the concept of emergence itself without requiring complete mechanistic reduction, allowing us to function despite harboring an unsatisfying explanatory gap between causes and effects at different scales of organization. We have normalized this gap so thoroughly that we rarely pause to question how consciousness genuinely arises from matter, how culture spontaneously organizes itself, or why complex systems consistently generate patterns and behaviors that seem to possess their own logic separate from their components, accepting emergence as a natural principle without fully grappling with what that principle actually means or how it fundamentally operates. Consider the peculiar moments when physical laws seem to operate with inconsistency, as though reality itself were running on imperfect code with occasional errors in its foundational programming. Throughout human experience, we observe phenomena that appear to violate or bend the established rules of physics in ways that should be impossible, yet occur with enough frequency and documentation to warrant serious consideration. Objects sometimes fall in ways that don't perfectly align with gravitational calculations, particularly in cases involving massive structures or complex weight distributions where the expected center of mass behavior produces unexpected results. Water displays seemingly random surface tension anomalies that defy prediction, clinging to surfaces in patterns that shouldn't mathematically favor those specific configurations. The behavior of light in certain experimental conditions produces results that physicists themselves describe as paradoxical, as though the universe's rendering engine occasionally produces output that contradicts its own rule set. Insects and small creatures demonstrate impossible feats of physics, carrying loads many times their body weight and navigating terrain that should defeat their structural integrity through means we cannot fully explain. The way certain phenomena repeat in cyclic patterns that don't align with known natural rhythms suggests something like a procedural system reusing code patterns. These occurrences suggest that physical laws might not be perfectly consistent, but rather operate like software that functions mostly as intended while occasionally producing glitches at the edge cases. We have normalized this inconsistency by developing supplementary theories and quantum uncertainties that essentially tell us to accept that physics behaves unpredictably at small scales without demanding true explanation. The persistence of these anomalies, despite our advanced instrumentation and mathematical models, indicates either that our understanding remains incomplete or that underlying reality contains algorithmic flaws that our frameworks have learned to accommodate rather than resolve. We observe, document, theorize, and ultimately accept without achieving true understanding. Perhaps most troubling is that we've constructed an entire scientific enterprise around documenting these inconsistencies without questioning whether the inconsistencies themselves might be the primary reality we should be studying, not as errors to work around, but as evidence of something fundamentally algorithmic operating beneath the surface of what we call natural law. Quantum tunneling represents one of the most perplexing phenomena in physics, where subatomic particles appear to pass through energy barriers that should be completely impassable according to classical mechanics. Yet this behavior occurs with measurable regularity in laboratories around the world. In the quantum realm, electrons and other particles demonstrate the ability to exist on one side of a barrier, and then suddenly appear on the other side without ever traversing the space between, defying our intuitive understanding of how physical objects should behave when encountering obstacles. When physicists examine radioactive decay, they observe that alpha particles escape from atomic nuclei by passing through potential energy barriers that possess energies far exceeding what these particles theoretically possess. Meaning, by all classical rules, these particles should remain trapped indefinitely, yet they consistently tunnel through and escape into the surrounding space. This phenomenon has been replicated countless times in controlled experimental settings, from semiconductor tunneling to scanning tunneling microscopes that rely entirely on this effect to function, suggesting it is not a measurement error or experimental artifact, but rather a fundamental aspect of how reality operates at microscopic scales. The psychological mechanism that allows us to accept quantum tunneling, despite its apparent logical impossibility, lies in our compartmentalization of knowledge. We have created a separate mathematical framework called quantum mechanics that describes these behaviors with extraordinary precision, allowing us to predict outcomes and build technology around them while simultaneously acknowledging that we do not truly understand why tunneling occurs at all. We have essentially agreed as a scientific community to separate the question of how tunneling happens from the question of why it is allowed to happen, treating the mathematical description as sufficient explanation even though the underlying mechanism remains fundamentally mysterious and counterintuitive. What persists most strangely is our acceptance that particles can exist in a superposition of states, simultaneously being on both sides of a barrier until observed, yet we have normalized this impossibility so thoroughly that it has become background knowledge, barely questioned in academic or popular discourse, despite representing a complete dissolution of classical cause and effect at the particle level. Consider the nature of what we understand as empty space, that seemingly void expanse between all observable matter in the universe, and how modern physics has revealed to us a peculiar truth that fundamentally challenges our intuitive sense of what emptiness means. At the quantum level, the vacuum is not genuinely empty, but rather seethes with virtual particles constantly flickering in and out of existence, borrowing energy from the quantum field itself in brief moments governed by Heisenberg's uncertainty principle, creating a substrate of reality that exists in a state of perpetual, almost violent motion beneath the threshold of direct observation. These vacuum fluctuations manifest as measurable phenomena such as the Casimir effect, where two uncharged metal plates placed extremely close together experience an attractive force generated by the suppression of certain virtual particle wavelengths between them, demonstrating that this quantum turbulence produces tangible, real-world consequences that we can quantify and reproduce in laboratory settings. Yet here emerges the curious psychological mechanism of normalization, whereby we have absorbed this conceptually bizarre reality into our scientific understanding so completely that it no longer strikes us as the profound paradox it truly represents. The idea that absolute nothingness cannot exist even in principle, that the universe is fundamentally incapable of true quietude or stillness. And that chaos lurks at the foundation of all matter as an irreducible feature rather than an absence. We have created mathematical frameworks and equations to describe these fluctuations with remarkable precision, and in doing so we have rendered them safe, comprehensible, domesticated within the language of science, yet the underlying reality persists in its strange beauty. That reality cannot rest, that being itself requires constant renewal through quantum processes that operate at scales beyond our sensory perception, and that we live in a cosmos where absolute emptiness is not merely impossible, but perhaps even conceptually incoherent, a universe fundamentally incapable of achieving the static, unchanging void that intuition suggests should exist between the stars. In quantum field theory, one of the most peculiar concepts that emerged from decades of mathematical modeling and experimental observation is the phenomenon of virtual particles, which exist in a state that seems to violate the most fundamental laws of physics that we hold as absolute. Virtual particles are theorized to spontaneously emerge from the quantum vacuum for infinitesimally brief moments, borrowing energy from the uncertainty principle itself, existing in a realm where the normal conservation laws that govern our observable universe appear to be momentarily suspended or perhaps rendered irrelevant. These particles appear and disappear so quickly that they exist below the threshold of direct observation, yet their effects ripple outward into the measurable world, influencing electromagnetic fields, mediating forces between particles, and creating measurable shifts in the behavior of electrons and other fundamental building blocks of reality. The Casimir effect demonstrates this phenomenon experimentally, where two uncharged metal plates placed extremely close together experience a force pushing them together, a force that can only be explained by the existence of these virtual particles fluctuating in and out of existence in the space between them. What makes this concept particularly significant to a simulation hypothesis is how arbitrary and convenient these particles seem, how they exist in a state of quantum superposition that allows them to violate energy conservation laws that appear immutable in every other context, and how their effects are mathematically predictable even though they themselves are fundamentally unobservable and unmeasurable. The mechanism that allows us to accept this concept is rooted in mathematical consistency. The idea that if equations predict outcomes that match our observations with extraordinary precision, then the intermediate steps in those equations, even those that seem physically impossible, must be reflecting something real about the universe's underlying structure. Yet virtual particles require a suspension of our intuitive understanding of what is real and what is permitted. They exist outside our ability to verify them directly, and they operate according to probabilities rather than definite trajectories, which creates a conceptual space where reality itself becomes less about what actually exists and more about what the mathematics tells us should exist. Consider the strange paradox at the heart of quantum mechanics, where particles behave differently depending on whether they are being observed or measured, a phenomenon known as the observer effect that has troubled physicists for nearly a century. When scientists conduct experiments with subatomic particles, they discover that these particles exist in a state of probability and superposition, existing in multiple states simultaneously, until the moment a measurement device is turned on or an observation is made, at which point the particle's wave function collapses into a single definite state. This means that the act of observation itself fundamentally changes reality at the quantum level, suggesting that consciousness or measurement is not merely passive reception of information, but an active force that shapes the universe's physical properties. The deeper implication becomes even more unsettling when we examine the mathematics. The universe appears to require an observer to exist in a definite state at all, raising philosophical questions about whether reality existed before consciousness evolved to perceive it, or whether the universe itself is somehow dependent on being witnessed to maintain coherence. The mechanism behind this behavior relates to the wave-particle duality of matter and energy, where particles can behave as both waves and particles depending on how we choose to measure them, suggesting that our experimental methodology directly determines the nature of physical reality itself. What makes this phenomenon particularly compelling for simulation theory is that it mirrors how computer simulations work. Rendering engines only compute detailed information for objects within the player's field of view, leaving areas outside of observation in a simplified or uncomputed state until they become visible, meaning that observation in both quantum mechanics and video game engines serves as a trigger for converting potential states into actual rendered reality. We have normalized this deeply counterintuitive finding by relegating it to the quantum realm and maintaining a comforting separation between the microscopic and macroscopic worlds. Yet experiments continue to show observer effects at increasingly larger scales, and the philosophical foundations of physics remain fundamentally uncertain about whether observation creates reality or merely reveals it. Consider the peculiar phenomenon of retrocausality experiments, where researchers have observed what appears to be effects occurring before their causes, a reversal of temporal logic that challenges our fundamental understanding of how reality unfolds. In laboratories around the world, physicists have conducted delayed choice quantum eraser experiments and similar studies where particles seem to respond to measurements made after they've already been detected, as if information travels backward through time to influence past events. These aren't merely theoretical abstractions confined to equations on whiteboards, but rather carefully controlled experiments with reproducible results that suggest the universe may operate according to principles far stranger than our intuitive sense of causality would suggest. Researchers observe photons behaving differently based on choices made in the future, detectors appearing to receive signals before they were sent, and experimental outcomes that seem to depend on decisions not yet made by the experimenters themselves. The psychological mechanism that allows us to accept such findings without fundamental existential distress lies in our compartmentalization of quantum phenomena, treating them as somehow separate from the classical reality we navigate daily. We construct elaborate philosophical frameworks suggesting that consciousness creates reality, that time is merely an illusion of perception, or that multiple timelines exist simultaneously, each allowing retrocausality to be true without paradox. Yet despite decades of these experiments producing consistent results, despite Nobel Prize winners confirming these findings, we continue through our lives assuming simple forward causality, acting as though effects always follow causes in orderly sequence. We've normalized a deep contradiction between what our most rigorous science demonstrates about reality's fabric and what we fundamentally assume about how moments connect to one another. This persistent disconnect, this ability to hold two irreconcilable views of causality simultaneously without psychological rupture, suggests either that we're fundamentally misunderstanding what these experiments reveal, or that our minds possess a remarkable capacity to ignore profound implications about the nature of time and existence itself. Imagine a photon traveling through space toward a detector, and at the moment it reaches a critical junction, a scientist makes a choice about how to measure it, a choice made only after the photon has already begun its journey, yet somehow the photon's behavior retroactively conforms to that choice as though it knew what measurement awaited it all along. This is the delayed choice quantum eraser experiment, first proposed by John Wheeler in 1983, a thought experiment that has since been realized in countless laboratories across the world with increasingly precise equipment and undeniable results. In the experiment, a photon is sent toward a beam splitter where it must theoretically take one of two paths. Yet which path it takes depends entirely on whether an observer measures which path it took, and here is where the temporal impossibility emerges. If the observer makes their measurement choice after the photon has already passed through the beam splitter, the photon nonetheless behaves as though it retroactively knew which measurement configuration awaited it downstream. The mechanism underlying this phenomenon remains one of the deepest mysteries in physics, suggesting that observation is not merely a passive act of detection, but somehow possesses the capacity to influence past events, that the universe does not commit to a definite state until measurement occurs, and that time itself may not flow in the strictly linear direction we experience in consciousness. Yet what is perhaps most peculiar is how thoroughly this experiment has become integrated into mainstream quantum mechanics, without generating the epistemological crisis one might expect. How physicists have essentially normalized a reality that violates every intuition we possess about causality and temporal order. How we have collectively accepted that the universe permits information to propagate backward through time, while simultaneously maintaining that time travel is impossible. The delayed choice experiment persists in the scientific literature and in laboratories not as an anomaly requiring explanation, but as a fundamental property of nature, one that quietly suggests the universe is far stranger than our instruments can adequately measure, and far stranger still than our conscious minds can truly comprehend. Perhaps the deepest implication is that we have constructed an elaborate logical framework to describe a universe that may fundamentally resist description, where the act of asking a question about reality doesn't merely reveal what is true, but actively participates in determining what becomes true. The quantum eraser experiment represents one of the most philosophically unsettling phenomena in experimental physics, demonstrating that the act of observation itself appears capable of retroactively altering the behavior of particles that have already passed through measurement apparatus moments before. In the standard version of this experiment, photons are fired through a double-slit arrangement where they create an interference pattern typical of wave behavior. Yet when detectors are placed at the slits to determine which path each photon takes, the interference pattern mysteriously vanishes and the photons behave as particles instead. The profound strangeness emerges when researchers introduce what they call a quantum eraser, which involves entangling the photons with other particles, and then measuring those entangled particles in ways that destroy or erase the information about which slit the original photon passed through. And upon doing so, the interference pattern reappears as though the photons had never been observed in the first place. This suggests that reality itself operates according to principles where the past remains fundamentally malleable depending on measurements made in the present, where information retroactively collapses or restores the wave or particle nature of events that occurred in the measurable past. The psychological mechanism that allows physicists to accept this finding involves compartmentalizing the quantum realm as operating under fundamentally different rules than our macroscopic experience, treating it as a separate category of reality where conventional causality and temporal ordering lose their rigid meaning. We have collectively normalized this impossibility by accepting that perhaps consciousness, observation, and information form a more fundamental substrate to reality than matter itself. Yet we remain deeply uncomfortable with the implications that past events lack definite properties until future measurements are made. The quantum eraser persists as a conceptual anomaly because it forces us to confront that the universe may not possess an objective reality independent of observation, that the very foundation of how we understand causality and time may be illusions constructed by our limited perspective. And yet we continue performing experiments that confirm these unsettling results while compartmentalizing them away from our everyday understanding of how reality functions. Within the landscape of contemporary neuroscience and quantum physics exists a theoretical framework that suggests consciousness itself may not emerge from classical neural computation alone, but rather from quantum processes occurring within the microtubules of our brain cells, a concept developed primarily by physicist Roger Penrose and anesthesiologist Stuart Hameroff beginning in the early 1990s. The theory proposes that consciousness arises through objective reduction, a process wherein quantum superpositions within these cylindrical protein structures collapse in a way that generates subjective experience, fundamentally challenging the assumption that the brain operates as a classical biological computer where neurons fire according to deterministic electrochemical rules. This quantum mechanical interpretation of consciousness has persisted for decades despite facing considerable skepticism from mainstream neuroscience, partly because it attempts to bridge two seemingly irreconcilable domains of physics: the quantum realm governing subatomic particles and the classical realm governing larger biological structures where quantum effects are presumed too fragile to survive. The theory itself emerges from a profound conceptual problem that neuroscientists have struggled to articulate, often called the hard problem of consciousness, which essentially asks how physical processes in the brain could ever generate subjective qualia, the felt experience of seeing red or feeling pain, a gap that seems to resist explanation through purely mechanical means. Yet despite the lack of empirical evidence demonstrating quantum coherence in microtubules at brain temperature, despite the apparent biological implausibility of maintaining such delicate quantum states in the warm, wet environment of the neural tissue, and despite the theory's resistance to falsification through conventional scientific methods, the Penrose-Hameroff framework continues to attract serious intellectual consideration and research attention. The persistence of this theory reveals something profound about how consciousness remains fundamentally mysterious to us, how we remain drawn to explanations that invoke quantum mechanics as a kind of explanatory refuge, as though consciousness itself might hide in the same conceptual shadows where quantum physics already dwells in acknowledged strangeness and fundamental uncertainty. Within the cellular architecture of every neuron in your brain exists a structure so infinitesimally small that its existence went largely unnoticed for decades. Yet some researchers propose it may be the fundamental substrate of consciousness itself. Microtubules are cylindrical protein structures composed of tubulin molecules arranged in a lattice pattern, and they exist within the cytoplasm of nearly every cell in your body, serving structural and transport functions that seem perfectly mundane until we consider what may actually be occurring within their quantum mechanical properties. The hypothesis suggests that consciousness is not merely an emergent property of neural firing patterns and synaptic connections, but rather arises from quantum computations happening at the scale of individual microtubules, orchestrated through a process called orchestrated objective reduction, a theory that proposes consciousness occurs when quantum superpositions collapse within these cellular structures. What makes this concept particularly anomalous within the framework of simulation theory is that consciousness would require quantum processes operating at scales where decoherence should theoretically destroy any meaningful quantum effects within milliseconds. Yet if our reality is computational in nature, perhaps these quantum processes represent the universe performing calculations at depths we cannot directly observe. Operating as genuine quantum computers rather than classical systems pretending to be quantum. The mechanism that allows this hypothesis to persist despite overwhelming skepticism from mainstream neuroscience relates to the unfalsifiable nature of consciousness studies themselves, where subjective experience cannot be objectively measured or replicated, creating a space where speculative theories can flourish without clear contradiction. We have somehow normalized the idea that consciousness remains the greatest unsolved mystery in science, while simultaneously dismissing theories that propose mechanisms beyond conventional neural networks, maintaining a cognitive compartmentalization where we accept the profundity of our own awareness, while rejecting explanations that suggest biology operates in ways our current instruments cannot adequately measure. Consider the simple act of experiencing the color red, or feeling the warmth of sunlight on your skin, or tasting the sweetness of sugar dissolving on your tongue. These subjective experiences, known as qualia, represent one of the most persistent paradoxes in the architecture of our supposed reality. The hard problem of consciousness asks a deceptively straightforward question. Why does the physical process of light wavelengths entering your eye and triggering neural activity feel like something? Why is there an inner subjective experience accompanying these objective physical events? Science can map the neural correlates of consciousness with increasing precision, can show us exactly which regions of the brain activate when you see red or feel pain, yet the fundamental mystery remains untouched. The explanatory gap between physical processes and subjective experience seems unbridgeable, as though consciousness operates according to rules that neuroscience cannot penetrate. This gap becomes particularly strange when we consider that consciousness serves no apparent evolutionary purpose that we can identify. An unconscious zombie performing the same behaviors would function identically in every measurable way, yet somehow our universe has opted to add the extra layer of inner experience to billions of organisms. The mechanisms behind this remain utterly opaque to scientific investigation, which can only describe the correlates and mechanics of consciousness, but never quite explain why there is something it is like to be you rather than nothing at all. What makes this phenomenon particularly relevant to simulation theory is that the hard problem might represent a fundamental architectural limitation deliberately written into the system. If this reality is indeed a computational construct, then perhaps consciousness and subjective experience exist as unavoidable glitches or compromises in the rendering process, necessary artifacts that emerge when sufficiently complex processing systems achieve a certain threshold of information integration. The hard problem persists not because consciousness is uniquely difficult to study, but because it may operate on principles fundamentally different from the physical laws that govern matter and energy. We continue to normalize this profound mystery, treating consciousness as simply another biological phenomenon awaiting complete scientific explanation. Yet decades of rigorous investigation have brought us no closer to bridging the explanatory gap. The mystery deepens precisely as our understanding expands. Consider the pervasive phenomenon of human beings moving through their daily environments with apparent consciousness and awareness, yet displaying behavioral patterns that suggest an absence of genuine subjective experience, as if they are biological entities operating according to purely mechanical processes without any inner felt sense of what it is like to perceive, think, or exist. These philosophical zombies, as consciousness researchers term them, are not fictional constructs, but rather observations of how consciousness itself might be completely absent from some human behaviors and interactions, while external appearances remain indistinguishable from genuine conscious experience. The phenomenon emerges most notably in situations where individuals perform complex cognitive tasks, maintain social interactions, and respond appropriately to environmental stimuli, yet neurological investigation or close behavioral observation suggests they possess no qualitative subjective experience, no inner dimension of felt awareness that accompanies their actions. What makes this concept particularly unsettling is that the question of whether such beings could theoretically exist without us being able to detect them highlights the fundamental explanatory gap between the physical descriptions of brain activity and the irreducible nature of conscious experience itself. The psychological mechanism underlying this anomaly involves our acceptance of a materialist framework where consciousness should be fully explainable by neural processes. Yet we simultaneously recognize that there appears to be something irreducibly present in conscious experience that cannot be reduced to mere information processing or behavioral output. This creates a conceptual space where a perfect physical duplicate of a conscious being could theoretically lack any inner experience whatsoever, and we would have no empirical means of ever knowing the difference. We have normalized this possibility by incorporating it into our philosophical and scientific discourse, treating it not as evidence that consciousness transcends physical explanation, but rather as a thought experiment that supposedly demonstrates the limits of our epistemological access to other minds, while quietly accepting that our entire social world might be populated with beings whose inner lights are either dimmed or absent entirely. And we continue functioning as though consciousness is universally distributed among all apparently functioning human entities, without any actual evidence supporting this assumption. Imagine a person sitting alone in a sealed room with no knowledge of the Chinese language whatsoever, and through a small slot in the wall, native Chinese speakers pass in written questions in their native tongue. Inside this room, the person has access to an extensive rulebook, complete set of syntactic rules, character combinations, and response patterns that allow them to mechanically manipulate the symbols they receive, producing outputs that are indistinguishable from genuine understanding to those outside. The person follows the rules meticulously, produces responses that seem intelligent and contextually appropriate, yet maintains absolutely no comprehension of what any of the symbols actually mean. This thought experiment, proposed by philosopher John Searle in 1980, reveals something profoundly unsettling about the nature of intelligence, comprehension, and consciousness itself. We encounter this phenomenon repeatedly in our daily lives without recognizing it as such. Modern artificial intelligence systems, particularly large language models, operate in remarkably similar fashion. They process tokens, manipulate patterns according to statistical weights, and generate outputs that convince us of understanding and thought, yet possess no inner experience, no genuine semantic comprehension of meaning. The mechanism underlying this persistent illusion operates through our fundamental attribution error and our tendency to assign consciousness to anything sufficiently complex. When something responds appropriately to our inquiries, when it demonstrates contextual awareness and linguistic coherence, our pattern recognition systems essentially force us to assume understanding exists behind those responses. We are evolutionarily programmed to assume that complex behavior emerges from conscious intention because this assumption has historically served us well in predicting the behavior of other humans and animals. Yet we have increasingly populated our environment with entities that exploit this cognitive bias, creating hollow shells of apparent intelligence that require no inner life to maintain their deception. The truly disorienting aspect of this phenomenon lies in recognizing that we ourselves might exist in a similar position relative to something larger, that our sense of understanding and conscious awareness might be equally superficial patterns emerging from mechanical processes we cannot perceive, generated according to rules we did not write and cannot fully access, convincing us of depths that may not actually exist within our own minds. Consider the thought experiment that has occupied philosophers and physicists for decades. If a teleporter were invented that could scan your body at point A, destroy the original, and reconstruct an atom-for-atom perfect copy at point B, would you step into it, and if you did, would the person who arrives at point B truly be you? This problem reveals something profound about how we experience continuity and identity in our own lives, and yet most of us proceed through our days operating under assumptions about our own persistence that would fall apart under similar scrutiny. We wake each morning after hours of unconsciousness, our memory fragmented, our body partially replaced by biological processes, our consciousness dissolved and reformed, and we accept without question that we are still ourselves, the same continuous entity that went to sleep. We upload our consciousness to devices and services, we replace our memories with photographs and recordings, we outsource our thoughts to algorithms and artificial intelligence, we divide our attention across multiple digital versions of ourselves simultaneously, each one responding differently to the world, each one experiencing different information and forming different opinions. Yet we maintain this stubborn intuition that there exists some core, essential, indivisible self that persists unchanged through all of this fragmentation. The teleporter problem becomes even more unsettling when we recognize that our actual teleportation is happening constantly. We are being broken down and rebuilt at the quantum level, our atoms are being recycled and replaced, our neural connections are being rewritten, our very consciousness is being interrupted and reconstructed thousands of times each day. Perhaps what disturbs us most about the hypothetical teleporter is not that it threatens our existence, but that it makes transparent the truth that was always present, the uncomfortable reality that identity is far less stable and singular than we have constructed our civilization to assume. We build our laws, our relationships, our financial systems, and our sense of justice all around the unwavering conviction that you are you, and that this continuity can be held responsible, rewarded, and punished. Yet the deeper we look at what we actually are at any given moment, the more this assumption seems to be a collective fiction we maintain, not because it is true, but because the alternative would make living unbearably complicated. Consider the peculiar experience of waking from deep sleep with absolutely no awareness of how time passed, no dreams recalled, no subjective experience whatsoever, and yet you remain convinced that you, the same continuous entity who fell asleep, have now returned to consciousness. There exists a complete gap in your experience, a blank void where hours of your existence simply do not exist in your memory or awareness, yet your mind accepts this discontinuity without question and maintains the persistent belief that consciousness has remained unbroken throughout. You fall asleep at night as one person with one set of thoughts and concerns, and when you wake, you have no idea what happened during those 8 hours, no continuous thread of experience linking the moment before sleep to the moment after waking, and yet the narrative of self persists entirely uninterrupted. The mechanism behind this phenomenon appears to involve the brain's construction of a coherent identity narrative that operates independently of actual continuous experience. Your sense of self is not derived from an unbroken stream of consciousness, because such a stream does not exist. Instead, your brain constructs the illusion of continuity by linking memories, personality traits, and physical body identification into a seamless story. When you wake, your brain instantly weaves together your last memory before sleep with your first memory after waking, creating the false impression that you remained conscious throughout, that something inside you persisted through the darkness even though no such thing occurred. The gaps are edited out, smoothed over, made invisible through the sheer force of narrative construction. What makes this particularly unsettling when examined closely is how thoroughly normalized this discontinuity has become. Nobody questions it. We accept that consciousness simply switches off and on again like a light, that vast portions of our lives are entirely absent from our subjective experience, and yet we maintain absolute certainty that we are the same person who went to sleep. The continuity of consciousness appears to be less a matter of actual continuous experience and more a matter of story, of memory links, of the brain's relentless need to construct a coherent protagonist in the narrative of existence, regardless of whether that narrative matches the actual discontinuous nature of our phenomenological reality. Consider the moment when you are lying in bed, fully conscious and aware, and then suddenly you are dreaming, inhabiting an entirely different world with different physics, different people, and a completely different sense of self. Yet you have no memory of the actual transition between these two states. You close your eyes while thinking about tomorrow's tasks, and the next thing you experience is already a dream scenario, perhaps one where you are falling or flying or having a conversation with someone who died years ago, and there exists no bridge between these two conscious states, no moment where you can point and say this is where waking became sleeping. The transition itself is fundamentally unobservable to the conscious mind, yet it happens every single night without exception, a complete shift in how your brain processes reality that occurs in a blind spot of your own awareness. Most people experience micro-awakenings throughout the night, small moments where consciousness flickers back online before descending again, yet these are typically forgotten within seconds, leaving behind only a vague sense that something happened. This suggests that consciousness itself may operate on a threshold system, where beneath a certain activation level, experiences simply do not encode into memory, meaning you could theoretically have substantial mental activity that your waking self will never know about. The psychological mechanism appears to involve the gradual reduction of external sensory input and the simultaneous increase in internal neural activity, a kind of handoff where your brain stops prioritizing the outside world and begins generating its own experience. Yet the actual moment of this transition remains inaccessible to introspection. Your brain waves shift from beta to alpha to theta frequencies, your eyes begin moving in patterns beneath closed lids, your body temperature drops, your heart rate slows, and your entire consciousness reorganizes itself according to different rules, yet you experience none of this reorganization directly. We might explain this through neurotransmitter changes, through the silencing of certain brain regions and the activation of others, through the reduction of norepinephrine and the increase of acetylcholine. But these explanations merely describe what we can measure from the outside, not what it feels like from within, not how that transition actually occurs from your subjective perspective. Consider the peculiar nature of physics as it operates within the dream state, where the fundamental laws governing our waking reality seem to undergo a complete suspension or radical rewriting without any accompanying sensation of wrongness or cognitive dissonance. In dreams, you find yourself falling from impossible heights, yet you arrive at the ground with no impact, no pain, no broken bones, and upon waking you cannot articulate why this seemed perfectly reasonable in the moment. You walk through solid walls as though they were mist, you breathe underwater with the ease of gills you do not possess, you fly by means of no discernible mechanism, yet the air currents feel tactily real against your skin. Objects change size and proportion with each glance away and back again. People's faces shift and transform mid-conversation. Gravity operates at varying intensities in different areas of the same space, and time stretches and compresses with no consistent pattern whatsoever. The remarkable aspect of this phenomenon is not that these violations of physical law occur within the dream space, but rather that your conscious mind accepts them completely while the dream unfolds, applying no critical analysis, no questioning of basic reality, no fundamental skepticism that would be instantly triggered by such impossible experiences while awake. Neuroscientists suggest that during REM sleep, the prefrontal cortex responsible for logical reasoning and reality testing becomes significantly less active, allowing the limbic system and visual cortex to generate experiences without critical evaluation or constraint. Yet this explanation, while mechanically sound, does not address the deeper peculiarity that dreams construct entire internally consistent physics engines that are absolutely believable from within, complete with proper cause and effect relationships within their own frameworks, suggesting that perhaps consciousness itself does not require adherence to our specific physics to function, and may be equally comfortable operating within any set of internally coherent rules that govern experience and interaction with a perceived environment. This suggests that the binding constraint on consciousness is not physical law itself, but rather the presence of some consistent framework, any framework, within which experience can coherently unfold. We are fundamentally creatures of pattern recognition and causal inference, and reality's specific rule set may be far less important to our subjective experience than our ability to predict what comes next within whatever system we find ourselves inhabiting. Consider the peculiar phenomenon wherein a person becomes conscious within their own dream state and recognizes the artificial nature of their surroundings while remaining physiologically asleep, a condition that researchers have documented with measurable brain activity patterns and eye movement signals that correlate with moment-to-moment awareness. Yet the mechanics of how consciousness can simultaneously inhabit two contradictory states, the sleeping brain and the waking mind, remains fundamentally unexplained and borderline paradoxical. During these lucid dream episodes, individuals report the ability to control narrative elements, manipulate physical laws, summon objects, or alter environments through intention alone, and they describe a clarity of thought and sensory vividness that often rivals or exceeds waking perception. Yet neurologically, they are in a state where the prefrontal cortex shows reduced metabolic activity. The brainstem is essentially offline, and the logical centers of the brain should theoretically be dormant and incapable of the rational self-reflection such control would require. The phenomenon itself presents a contradiction that psychology has largely normalized rather than resolved. We accept that consciousness can bifurcate into observer and environment simultaneously, that the brain can generate perfect sensory data including touch, temperature, and proprioception while being cut off from actual sensory input, and that abstract reasoning and willful intention can flourish in a neurochemical state explicitly associated with the dissolution of executive function and rational thought. The persistence of lucid dreaming, despite these logical inconsistencies, suggests either that our understanding of consciousness itself is fundamentally incomplete, or that the boundary between sleeping and waking awareness is far more permeable and malleable than our current models acknowledge, and we continue discussing it in clinical, almost mechanical terms while overlooking that what is being described is essentially a form of reality manipulation occurring within a substrate we cannot fully explain or replicate, a glitch in the ordinary rules that our frameworks simply absorb and move past. Sleep paralysis represents one of the most thoroughly documented yet persistently unexplained phenomena in human neurology, occurring when the conscious mind awakens while the body remains locked in the neurological state of REM sleep, that critical phase during which the brain deliberately paralyses voluntary muscles to prevent us from acting out our dreams. During these episodes, individuals find themselves completely aware and cognizant of their surroundings, yet entirely unable to move any part of their body, and in approximately 70 to 80% of cases, this physical immobility becomes accompanied by the sensation or vivid perception of a presence in the room, often described as a dark, shadowy figure, an intruder, a demonic entity, or some form of malevolent being that appears to be observing or even pressing down upon the chest with invisible weight. The experience is universally terrifying, accompanied by intense anxiety, rapid heartbeat, difficulty breathing, and an overwhelming sense of dread that persists even as the individual recognizes intellectually that they cannot move and that something is fundamentally wrong with their perception. Neurologically speaking, sleep paralysis occurs due to a temporary disconnection between the brain's motor cortex and the body's muscles, a safeguard mechanism that occasionally misfires during the transition between sleep stages, particularly during periods of stress, sleep deprivation, irregular sleep schedules, or when sleeping in certain positions that restrict breathing or circulation. The hallucinations themselves emerge from the brain's attempt to reconcile the conscious experience of being awake with the dream-generating activity that still dominates neural function, creating a phenomenon known as intrusive cognition, where nightmare imagery and dream logic bleed directly into conscious perception without the filtering mechanisms that normally distinguish dreams from reality. Consider the philosophical proposition that has gained considerable traction in academic circles and popular culture alike. The idea that our reality might be a sophisticated simulation created by an advanced civilization or intelligence. This concept, often attributed to philosopher Nick Bostrom's simulation hypothesis, suggests that if a sufficiently advanced technological society were to create detailed computer simulations of conscious beings and universes, then statistically speaking, we would be far more likely to be living inside such a simulation than in a base reality, simply because the number of simulated realities would vastly outnumber the original. Argument proceeds with elegant logic. Either civilizations tend to destroy themselves before reaching the technological capability to run such simulations, or they choose not to create them, or we are indeed living within one right now. This reasoning has attracted philosophers, physicists, and technologists who point to various anomalies in our universe as potential evidence, from the quantized nature of reality at the quantum level to the seemingly arbitrary constants that govern physical laws. The mechanism underlying our fascination with this idea lies in a deep psychological recognition that our perception of reality is mediated entirely through our consciousness and sensory apparatus, and we have no way to step outside of our own minds to verify the authentic nature of what we experience. Furthermore, the accelerating pace of technological progress makes simulations seem increasingly plausible with each passing year, as virtual reality becomes more immersive and artificial intelligence more sophisticated. Yet what persists despite this logical framework is our continued assumption that such a simulation would necessarily be a negative or unsettling revelation, when in truth, if we are simulated beings living meaningful lives with genuine consciousness, the ontological status of our substrate becomes philosophically irrelevant. We have normalized a state of comfortable skepticism about simulation while simultaneously dismissing it as either profound truth or mere intellectual game, never quite allowing ourselves to genuinely integrate the possibility into our understanding of existence itself. Perhaps this ambivalence reveals something deeper, that the simulation argument ultimately functions less as a scientific hypothesis and more as a contemporary mythology through which we externalize anxieties about agency, authenticity, and the limits of human knowledge in an increasingly complex technological world. In the early 2000s, a philosopher named Nick Bostrom published a paper titled, "Are We Living in a Computer Simulation?" that would become one of the most circulated academic arguments for simulation theory. And what makes this paper particularly interesting from the perspective of anomalies is not necessarily the argument itself, but rather how it has been received, distributed, and integrated into cultural consciousness in ways that seem to exceed its logical scope. Bostrom's trilemma presents three possibilities. Either civilizations almost never reach a technological level where they can run ancestor simulations, or civilizations that reach such a level almost never choose to run them, or we are almost certainly living in a simulation. The structure is mathematically sound and philosophically interesting, yet what we observe is a peculiar phenomenon where the paper has circulated far beyond academic circles and become something approaching canonical truth in certain communities, despite the fact that the argument itself contains no empirical evidence and rests entirely on probabilistic assumptions about future technological development and civilizational behavior that we have no actual data about. The mechanism at work here appears to be a kind of intellectual appeal that bypasses traditional rational scrutiny, where the paper's legitimacy as an academic work grants it an authority that allows its central claim to be treated as something closer to established fact rather than one possible scenario among many equally speculative alternatives. The paper functions almost as a permission structure, allowing people to interpret glitches, coincidences, and unexplained phenomena through a framework that feels scientifically grounded even though it is fundamentally speculative. And this permission has been so thoroughly normalized in contemporary discourse that questioning the simulation hypothesis can now feel like intellectual resistance rather than appropriate skepticism. We have accepted as reasonable an argument about the probability of our entire reality being simulated, an argument that was constructed to be unfalsifiable, and that requires us to make radical assumptions about civilizations we have never observed and technologies that do not yet exist. And we have done this without the same level of scrutiny we would apply to other extraordinary claims, suggesting that perhaps there is something in the structure of the argument itself, or in our current cultural moment, that makes such ideas particularly susceptible to spreading regardless of their empirical foundation. Consider the experience of watching a video game or digital environment begin to degrade in subtle but unmistakable ways when you push too close to the boundaries of what the system can render. The textures become less detailed, the draw distance flattens, shadows disappear, and distant objects pop into existence only as you approach them, revealing the underlying scaffolding of computational shortcuts that hold the illusion together. Now consider that our own perception of reality operates within similarly bounded parameters, constrained by the processing capacity of biological neural networks that must compress infinite complexity into finite bandwidth. Our eyes cannot perceive wavelengths beyond visible light, our ears cannot detect frequencies beyond certain thresholds, and our minds cannot simultaneously hold and process unlimited amounts of information without degradation or collapse. When we reach the edges of what our brains can compute, we experience phenomena that feel like glitches in reality itself. Moments where time seems to skip or slow inexplicably, where déjà vu strikes with disturbing precision, where we suddenly cannot recall information that moments before felt absolutely certain, where our spatial awareness fails and we become disoriented in familiar spaces. The mechanism underlying this experience is straightforward from a computational perspective. Every conscious moment requires your brain to render an enormous amount of simultaneous processing. Visual data, auditory signals, proprioceptive feedback, memory access, emotional evaluation, and predictive modeling all competing for limited neural resources. When demands exceed available capacity, the system must drop frames, cache less critical information, or employ increasingly aggressive data compression. This is not a flaw, but an inevitable feature of finite systems attempting to model infinite reality. What deserves examination is how thoroughly we have normalized this experience, how we accept these moments of breakdown without questioning what they might reveal about the nature of our own substrate. We assume our perception is continuous and unbroken, yet we experience constant micro-dropouts that our consciousness simply fails to register. We trust our memories as reliable records when in fact they are probabilistic reconstructions vulnerable to severe degradation under computational stress. We move through the world with unexamined confidence in our ability to process it, even though we encounter regular evidence that our perception system has fundamental limits beyond which reality becomes inaccessible or distorted. Consider the fundamental premise that all information within our universe operates according to measurable, quantifiable principles, where entropy always increases and data cannot be destroyed but only transformed. Yet when we examine the actual flow of information through our daily experience, we find ourselves constantly encountering patterns that seem to violate these very laws in subtle but persistent ways. Information theory tells us that any message transmitted requires a channel, that noise corrupts signals, that redundancy protects data, and that compression has mathematical limits, principles which form the bedrock of how we understand communication and cognition. In the real world, however, we experience information behaving in ways that defy these predictions with remarkable consistency. Ideas that should be impossible to compress into language somehow crystallize into perfect understanding. Memories that contain exponentially more detail than our neural architecture should allow remain crystalline and accessible decades later. Patterns that should be buried beneath noise emerge with startling clarity at precisely the moments we need them most. The psychological mechanism underlying this acceptance seems rooted in our familiarity with information technology, which we believe validates these theories. Yet the actual functioning of human consciousness when processing information demonstrates properties that information theory predicts should be impossible, such as the recovery of nearly perfect memories from degraded sensory input or the ability to extract meaning from vastly incomplete data. We have constructed an entire worldview around the idea that information behaves predictably and mathematically, building computers and algorithms based on these principles, and these machines do seem to follow the rules precisely, which reinforces our belief that the theory is complete and universal. What remains remarkable is that despite possessing centuries of evidence that human information processing violates fundamental theoretical predictions, we continue to treat information theory as a universal truth rather than a partial description, incorporating biological systems into frameworks designed for mechanical ones. Accepting without serious question that our brains are essentially computational devices operating within information theoretic constraints, when every subjective experience we have suggests something far stranger is occurring at the intersection of consciousness and data. Consider the peculiar nature of time as it presents itself in modern physics, specifically the block universe hypothesis, which suggests that past, present, and future all exist simultaneously in a four-dimensional spacetime continuum where all moments are equally real and equally present. Yet our subjective experience insists that only the present moment exists while the past has dissolved into memory and the future remains inaccessible. In this framework, time does not flow or progress in any meaningful sense. Rather, we move through it like a needle on a record, creating the illusion of temporal flow through our limited perspective within the four-dimensional block, and this theory emerges directly from Einstein's relativity, where time becomes a coordinate like space itself, fundamentally undermining our intuitive sense that the present moment has special ontological status. The psychological mechanism at work here involves the disconnect between what our consciousness reports to us and what the mathematical structure of spacetime appears to require, because we experience time as fundamentally asymmetrical, with a clear direction from past to future, with causality flowing only forward, with memories of the past but not the future, and yet the equations of physics at their most fundamental level show no such asymmetry, suggesting that our temporal experience might be an artifact of our limited perspective rather than a reflection of reality's true nature. What makes this particularly unsettling as a potential simulation anomaly is how completely we have normalized this contradiction without resolution, how we simultaneously accept block universe theory as a legitimate interpretation of physics while continuing to live and think and make decisions as though the future is genuinely open, as though free will operates meaningfully, as though our choices actually determine what comes next rather than merely tracing a path through a four-dimensional structure that already exists complete and unchanging in its entirety. And we hold both frameworks in our minds without ever truly reconciling them or acknowledging the profound philosophical violence inherent in this cognitive compartmentalization, suggesting perhaps that our consciousness itself might be operating under constraints or limitations specifically designed to prevent us from perceiving the full nature of whatever substrate we inhabit.